pipe specification called the 358. The big diameter pipes are made by bending a plate and longitudinal welding, and then go on increasing the length by butt welding. So that is one of those things gave a very unusual problem. Next slide, please. Yeah, so this happened again in a process flow, ammonia plant and then urea plant. I said urea plant down below is the one where 100% stainless steel. All the equipments are stainless steel, whereas the ammonia plant, all the equipments are carbon steel. And the urea reactor down below here, and the pipe connecting urea reactor and the recovery section suddenly failed. After a few, I would even say a few weeks of operation, not months of operation. I don't remember the exact time. So, but it is a very premature failure. Yeah, next slide, please. Yeah, this is the plant, and that is that particular red line connecting one vessel on the MB2, and then the heat exchanger E62 that is what it failed. That particular pipe failed. Nothing happened to any other, even though the same process is being used. Next slide, please. Yeah, and this is the ruptured section. You can see down below, it is made of 316L SS, very common stainless steel, 14-inch diameter, 8 mm thickness, which is a substantial thickness, 8 mm. And then it is specification ASTM A358, and which is what I mentioned, bending a pipe, longitudinal weld, and then butt weld. And that is the ruptured section. Next slide, please. Yeah, and you can see that it is a kind of a fish mouth failure. You can see on the red circle, and it's a huge plant, and it carries a very high temperature urea and ammonium carbamate solution, and which is a very highly corrosive solution. And thank God the plant is fully computer controlled, automation. Not many people are working there. You can see the size of the plant compared to a certain man standing on the floor. So, and fortunately, nobody was there, because it is a high temperature, high pressure urea, ammonia carbonate fluid suddenly bursting and then wetting the whole floor and whole equipment. So it is a very huge problem because of certain fabrication problem on that pipe. The next slide, please. You can see that we are seeing the close-up, what we call in the metallurgical industry fish mouth failure, fish opening, fish mouth failure. And it is the whole wall thickness from 8 mm, it has become very thin. And so it has reached a stage where, like you are putting your stent and blowing up in the heart. So the high pressure, it burst off like a balloon. Next slide, please. Yeah, and you can see, would you believe, if you walk around the pavilion, the stainless steel appearance is so much, and you cannot call this a stainless steel. Yeah, it is bad. And what we call it, this is an acceptable finish. In industry, chemical industry, stainless steel pipes are called white pickled finish. White pickled finish. As compared to the other industry, we call 2D finish, 2H finish, 3D finish, because they're specially polished ones. Whereas here we don't require a polish because the chemical industry application. It is a white pickled finish. But that is gone now. Now this pipe has become a dead body. So we do post-mortem analysis on this dead body. It cannot be used anymore. So that doing all these test results, we come to a conclusion. Next slide, please. Next slide. Somebody concentrate here. Listen. Yeah. Don't do two work at a time. Okay. And this is a close by. We have cut some samples for detailed testing just to make sure all the chemical properties, mechanical properties are alive, and nothing happened. Next slide, please. And this is the cross-section where we have taken sample, and the thickness has come down at a place where the ballooning has taken place, explosion has taken place. Next slide, please. Yeah, and you can see here, I'm going close by to the broken area, and next slide, please. Yeah, you can see there is some difference. I will not explain. I will not go into the deep explanation. There is two types of fracture on the 8 mm thickness. I'm looking at the 8 mm thickness cross section. So what you see here, north to south 8 mm, and then that is one half is chemically corroded, other half is a mechanical failure. Next one. And this is what you see at the bottom, that is the last mechanical failure. If you start bending a paper and broke it, the last one is called lip failure. And that is always common for any mechanical failure. On the first one will be corrosion failure. Next one. Yeah, this is a blowing up of the corrosion failure. You can see how the corrosion has taken place, roughening of the surface. You start with a uniform surface, but after 6 months of service, the whole surface is roughened. So some corrosion has taken place. Next one. Next one. Yeah, and this is the weld joint. And here suddenly, in the earlier one, you see something like a weld failure, but it is not a weld failure. Welding is perfectly okay. Only one half is split off, and so that means that one boundary, that weld metal, parent metal boundary is not good. Next one. Yeah, this is the surface area blown up into about 100, 200, 300 times. And you can see the surface is neither a uniform corrosion nor a mechanical crack. Some in between, you can see the circular type of attack. And this attack is called crevice corrosion. Next slide. Yeah, so the NDT, we also did success, you can call it success analysis. Why only this place is failed? Why not we go 1 meter high, 1 meter this way, look at the same pipe, do some testing. We did some testing. You can see radiography and ultrasonic testing have given rise to certain defects. It is not the pure linear indication in non-burst weld zones nearby. That means ultrasonic long separations. It is already there before you start putting the urea. So there is a typical fabrication defect. Next slide. So diagnosis, incomplete fusion of the parent metal and weld metal on the inside surface over a distance. Longitudinal crevice corrosion. Corrosion is, there are several forms of corrosion. If there is an area where my salt water can stagnate here, and that area will corrode, and that nothing else will corrode. And that is why it is called crevice corrosion. If you have got a geometric crevice in which liquid can go and stay put without any flow, that means it will be called crevice corrosion. That happened in this. So the weld metal is not completely fused, in which the liquid has gone inside and then led to this failure. Next slide. So specify 100% radiography of the longitudinal well. If they have done a good radiography of the pipe after fabrication, they would have rejected all these portions. But unfortunately, the specification allows either 10% inspection or 50% inspection or 100% inspection. 100% is an expensive affair. So people go either 50 or 10. In that possibility, the good ones are tested and bad ones are not tested. So that is the recommendation. It's a typical fabrication firm. The last case study before I hand over to Dr. Tanki. Next slide, please. This is the caustic cracking of SS tubes. This has happened in a pulp and paper industry. And the pulp and paper industry, you know how the paper is made. The wood is chipped and then dissolved in an alkali, and that is called pulp. And that pulp is rolled into rollers. Then you make hardboard, paper, and all that. So that alkali solution is called. It is handled in a big equipment called digester. So in one of those digesters requires a reheater, a stainless steel reheater in which the tubes are heated. The digestive solution is heated by surrounding steam, and that digestive is heated. It goes into the digester in which woods are packed. So this is a typical case. You'll see the. I cannot tell you in the beginning, because any such presentation you must keep the diagnosis at the end, like a crime story. Okay, you don't tell it in the beginning. Next slide, please. Yeah, this is you can see on the plant was running very satisfactorily for 8 years. You can see on the right side, the life is 8 years. That after 8 years, some cracking has developed, and then they replaced it. They replaced the entire one, and they wanted almost 10 times better life. So instead of increasing life, the replaced tubes, that is about down below 6 months, and that is what Earlier tube was 8 months, 8 years, and they faced this problem and they replaced it, and the life was only 6 months. So why this problem? So this is why it's a huge loss. It's a huge loss for them. Next slide, please. So this is the type of cracking and stainless steel showed. See, I'm sure there must be quite a few mechanical engineers. The difference between corrosion cracking and mechanical cracking, you bet a chalk piece and suddenly fails in one place. That is a maximum 4. So similarly, you take a steel and then bend, it will crack only at a particular place where maximum load. Whereas a stainless steel corrosion-induced cracking will start cracking at various places. So what you see, it's a multiple initiation. At several, what you see is the stainless steel inside surface where caustic was in contact. And so you can see multiple failure. This itself indicates that it is a corrosion failure and not a mechanical failure. Next one. And this is a service condition. You can see on the tube side, the white liquor, that is a term they used in pulp and paper industry. Sodium hydroxide, very, very highly concentrated caustic solution. Look at the temperature. It has to be heated so that the proper digestion takes place, 170 degrees centigrade, and the steam on the shell side. So this failure has occurred by exposure of stainless steel to caustic at 170 degrees centigrade. I'll take about 2 minutes only. Next slide, please. You can see the theoretical curve giving caustic concentration on the x-axis and temperature on the y-axis. It gives rise to various zones where such corrosion cracking can occur on 18-8 stainless steel or other 300 series of stainless steel. If you look at 170 degree on the right side and about 40% caustic, you are exactly right on the shaded region where caustic cracking can take place. Now the question is, why it does not happen on the earlier one, how it has given 8 years service, whereas the second one is a 6-month service. That is solved by doing a chemical analysis. Next one, please. So this is the A is the old sample, C is a new tube. We had conducted chemical analysis. Both are stainless steel, okay, so there is no point in chromium nickel. You can see what is the major difference. Can anybody point out what is the major difference? There is a major difference between the old tube and the new tube. Anybody can point out? It's very obvious. You look at the carbon content. The carbon is the old tube 068 and the new tube is only 027. So this means if you look at the inference, the old tube are 316 SS, whereas the new tubes are 316L SS. That makes a lot of difference. In fact, there must be some stainless steel manufacturers or melters also. 316L is 316L. Because of this L means lower carbon, it is more expensive. It is 15% more, 20% more expensive. So they have taken a decision, we go for a better material. 20% excessive means it should be better material. But unfortunately it is not. For this application it is not. Because the moment you reduce the carbon, you get into other problem, and that is shown in the next slide, please. That's shown in the next slide. You lose strength. If you reduce the carbon, you lose strength. And this is an application where stress corrosion is required. You require higher strength. The failure has occurred between two baffles. Between two baffles, there is a certain amount of vibration, and that is a load. And then if you put a softer material, the stress will be higher and lead to cracking. So this is a mistake done. So you must be very careful between 304 and 304L, 316 and 316L. So all these are all stainless steel gimmicks, in other words. So you must be very careful. So higher cost means it does not assume that it's a higher performance. So gentlemen, that is the last one. Next slide, please. Yeah, diagnosis, caustic stress corrosion cracking in both old and new tubes. Shorter life in new tubes because of lower strength. They have taken a lower strength, even though chemical composition same. Is there any more slide there? Thank you all. You can read something similar in our book written by Professor Raja of IIT and myself. And this book has been published by John Wiley, USA, about 4 or 5 years back. And there are hundreds of cases like that to discuss. Thank you very much. Yeah. I think we'll keep the questions then, and I'd like to invite Dr. Tanki. Okay? Yeah. And we and Dr. Tanki has got years of experience in fertilizer industry, and he has seen and he has interacted with the actual end users, and he has also interacted with the stainless steel suppliers. So he'll go and he'll going to make a short presentation on how to be very careful on welding and post-welding heat treatment. Dr. Tanki?
Thank you, Dr. Parimal. You made the thing so neat, clean. People have become.
You address them, please.
Oh, now, before that, I would like to be very much thankful to him because he has made the ball rolling and he has made you understand stainless steel by itself is a wonderful material. But once it is not been properly fabricated or not properly welded, you can assume a lot of problems. I have got only one case study to serve with you, and that will speak a lot that how much careful you should be while handling stainless steel material. So I will go very quickly to start with some preamble. Why these stainless steels are, what are the positive things, as Benjamin started telling so that we have to learn from the failure rather than success. So we are talking about the failure, and that failure should not get repeated all the time. So let us start with the first one. Yeah, start one by one. So here, so we are going on super duplex stainless steel, weldability and welding characteristics. Now SR super duplex stainless steel has been found wonderful material, and it has been designed to handle quite demanding situation, but somewhere some mistakes are done and we are not through. Going green, the major thing is like this. Going green and ensuring the highest sustainability with the world's energy resources is a growing necessity in the current age of business. Environmental awareness continues to be a key consideration for companies and their customers, and there is a growing need to cut carbon footprint. As such, industries across the globe continue seeking better methods of keeping their products environmentally friendly. That is to start with why stainless steel is. Next. Among the most commonly used green raw materials is stainless steel. Stainless steel is a fantastically green material because it is 100% recyclable. In fact, more than half of all the stainless steel materials that are in use today have been sourced from scrap materials. What's more, its production does not produce toxic runoff. That is the greatest thing. Individuals and business entities can make a huge difference by simply going for stainless steel rather than other non-recyclable raw materials. These are the benefits which I am praising stainless steel is how good it is. And that's why we have been always attracted to use stainless steel. Let us go next. Now, my study is with a super duplex stainless steel, in which we suffered, as a consultant in one of the companies, we suffered a lot. We went for this particular material for specific application, but it was a nightmare for us. Alloy 2507, UNS 3S32750 is a super duplex stainless steel with 25% chromium, 4% molybdenum, and 7% nickel designed for demanding applications which require exceptional strength and corrosion resistance, such as chemical process, petrochemical, and seawater equipment. Now, having known that seawater equipment means very high chloride content it can withstand against. And that was the reason why we went in some of the circuits in our process plant. The steel has excellent resistance to chloride stress corrosion cracking, high thermal conductivity, and a low coefficient of thermal expansion. The high chromium, molybdenum, and nitrogen levels provide excellent resistance to pitting, crevice, and general corrosion. Next. Modern duplex steels with significant nitrogen contents are readily weldable. However, welding strongly affects weldment properties, so correct welding procedures such as the heat input range, should be followed to obtain a correct weldment structure. This I am going a red signal over here. What is putting? Heat input range. The typical level of heat input used for duplex steels is 0.5 to 2.5 kilojoule per millimeter. For lean duplex and super duplex steels, the levels are, however, somewhat lower and more narrow. That means it demands a lot of precision. That means workmanship is demand for. If it is with a robotic, you will be having less problem. If you are dealing with a human being, those who are again controlled by various known parameters when there is the welding over there, and if it is not joined, problems are quite high, what we suffered. So I am trying to highlight this matter, how much you should be very careful to follow the instruction of the manufacturer, which we didn't give it much importance to it. Next, the duplex microstructure is more sensitive to the effect of subsequent passes compared to, for example, standard austerity grades. To reduce this effect of microstructure from previous passes, the interpass temperature should be maximized to 150 degrees centigrade for standard or lean duplex and 100 degrees centigrade for super duplex steels. I underline it. Instead of going 150, it should not go more than 100. Because of otherwise it is practice, no? That when we go for the welding, you would like to remove some moisture out of it, and so you weld it. And 100 degree temperature is just like it's ambient for for the material. So to find out the difference requires a lot of skill to handle it. Most types of stainless steel have good weldability and can be welded with all arc welding processes like GMAW, FCAW, GTAW, SMAW, and SAW. Dr. Perumal will be much more in good position being metallurgist to extrapolate the matter, but it is not the time at moment here. So stainless steel is used in many different applications for its strength, abrasion resistance, and corrosion resistance. Unfortunately, many assume it can be welded just like carbon steel. People have got this limitation to understand. It can be welded like carbon steel. In fact, this is the first and worst mistake that can be made, assuming it will weld and behave like carbon steel. Next. There are many grades of stainless steel. Since it is being a master class, I thought I should give him create the master in your mind to understand. That's why I given all these write-ups, sir. Please forgive me if you are knowledgeable in this case, but I think there is nothing wrong to go back and to refresh your mind what you studied in your college years. So there are many grades of stainless steel which have very different mechanical and chemical properties. Getting a sound understanding of stainless steel alloys, their properties, how to weld them, and how to select the right one for a given application is a science that very few have mastered. Dr. Perumal has shown many case studies with this particular paragraph. Many things are to be understood. This presentation will not attempt to provide a crash course in welding stainless steel. Instead, we want to focus on 5 of the most common mistakes made when welding stainless steel. 5 mistakes we should not repeat it. Mistakes you should definitely avoid, and particularly focus on mistake number 5, welding too hot. This was the problem with us, but let us see which are the remaining 4 mistakes are. Next. Mistake 1, assuming it welds just like carbon steel. This is the first mistake. Second mistake, using the same tools for both stainless steel and carbon steel. Isn't it, sir? Mistake 3, not knowing the type/grade of stainless you are welding on. And mistake 4, using the shielding gas as used for carbon steel. But mistake 5, welding too hot. Now we'll talk on this matter. Next. This is Super Duplex 2507, which was the material of construction in one of our process units. We had Super Duplex. Yes, sir. We had Super Duplex 2507 duct and another piping welding joint failure related issues which can be depicted as follows, which I try to show you here. And this is 34-inch Super Duplex weld joints cracked on HAZ, heat affected zone area. This was really a matter. Lot of study was done, just hold it. So lot of study was done before we thought of this material of construction. Laboratory experiments for the corrosion study, certain field study were carried out, and everywhere it was found good. And top management permitted, and they assigned the money to spend. And we spent millions of rupees to prepare this total duct. And when it failed, you understand, whom to blame? And as you know, okay, sir, just a minute, sir. Unfortunately, it was started a little late, sir. Huh? Anyway, and then we went in detail why it has failed. Next. These are some glimpses of a few weldment failure locations I have shown by this arrow. These are the area in this process plant it failed, cracked at the weldment. Next. Next, these are the areas. So we had the glimpses of a few weldment failure locations. Number of locations, there were some 18 to 20 locations. I have taken little few out of it. Next, our case. Metallographic microstructure study report of super duplex circulation loop of ammonium chloride plant was studied. It was observed that the welding procedure of this 2507 super duplex steel welding had not followed the standard procedure as per the guidelines. These are the structures of this, so I will not go in detail. Next. An overview of duplex welding. So please keep in mind, if you are using duplex stainless steel, these are the crux of the matter. Preheating of duplex stainless steel is not recommended and can have a detrimental impact on the properties of the welded assembly. To remove moisture, the duplex steel can be heated up to 100 degrees centigrade. The interpass temperature in welding it goes with, as a general rule, the interpass temperature should be limited to 150 degrees centigrade for linked duplex and duplex stainless steel, and 100 degrees centigrade for super duplex on which we are talking at the moment. Too high interpass temperature will decrease the cooling rate. In this case, intermetallic phase, nitrides or carbide precipitation is likely to occur in the weld metal. And last is the post-heating. Post-heating is not recommended and must be avoided if the temperature exceeds 200 degrees centigrade. These were the guidelines given by the manufacturer. Next. One of the primary objectives of any weld fabrication is to prevent weld defects, especially cracks. Cracks are the most severe of all weld defects and are unacceptable in most circumstances. Rework robs the company of precious time and material, that is money. So prevention is the primary concern. Crack don't always happen immediately after welding, and certain cracks, such as the underbead variety, may not be open to the weld surface. Cracks can develop over time after the weld has been subjected to loads while in service. Tensile and fatigue loads, bending, twisting, or flexing, as well as hot and cold expansion and contraction, all can occur long after welding, be it in 2 days, 2 months, or even 2 years. So the major cause of crack is when internal stresses exceed the strength of the weld metal, the base metal, or both. And once a focal point of this stress is, that is a stress riser, develops and accumulates, a crack can propagate. There are 2 slides now only. Next. Now the buck stops where? Whom to blame? That is the major criteria in the companies, which I have gone through many times. When you are found guilty or others are guilty. And who is more vocal? Who is more, he will get free. The responsibilities of both welder and supervisor affect weld quality. The welder is responsible for the defect when it is due to skill level or weld deposition techniques. Weld characteristics like incomplete fusion, excessive concave or convex bead contour, and improper weld size all can come from poor welding technique, improper travel speed, poor electrode manipulation, incorrect weld parameter settings, as well as failure to notify supervision of a problem with the job at hand. Ensure welders are using the correct base and filler metal, have proper weld procedure testing, work with adequate and functional welding equipment, receive effective and meaningful welder training, and work with properly designed accessible weld joints. Next and last. So we strictly followed the guidelines offered by super duplex stainless steel manufacturer in super duplex 2507 duct and another piping welding joints, and could tide over the problem which had created the nightmare to maintenance engineers with loss of production and unsafe operating conditions. This I submit like this, sir. I think this last. Thank you.
Thank you, Dr. Talki.
Thank you. I could adhere to the time, sir. Now questions are there for the class?
Yeah, please. I suggest, I think you must have got a feeling that handling, yeah, sorry. You must have got a feeling in these two presentations, handling stainless steel requires a lot of care. And handling our cooking vessel does not require that much care. but then, but then making process equipment and dealing with hot hydrocarbon gases, so it requires a lot of care. And welding is the very first one. And welding itself, it cannot be covered by Dr. Tanki in only 10 minutes presentation. There's going to be an international conference purely on stainless steel welding, I think in a couple of months now, by the Welding Society of Pune chapter of Indian Welding Society. So that means it's a huge topic by itself. So any defect occurring in stainless steel leading to major failure is a subject of concern. So I think we made really a good attempt to cover all these aspects in about 40 minutes of presentation. I'm sure there must be some questions. We will be very delighted to answer your questions, depending on how much Virgo gives time. Okay, thank you. Thank you. Yeah, please come forward. Anything, don't be hesitant. Let it be fundamental or let it be your problem or whatever.
माइक का वॉल्यूम
Yes,
थोड़ा बढ़ाइएगा.
Dr. Prasad is like to ask some questions. We know each other.
Thank you, doctors, for the presentation. It was wonderful.
Yeah?
It was wonderful. And now let's get started with the Q&A session. So I'm sure like we have few questions from here and there as well. So we'll start from you.
Yeah, sure.
Oh, we already have somebody.
He
अरे,
has already stood up.
sir, actually इन्होंने मुझे पहले ही बोल दिया था मुझे एक बात करनी है तो yeah. Sorry, yeah.
First of all, thank you, Dr. Perumal.
Yes.
I'm not here to ask you questions because you are a grandfather of this corrosion area.
Yeah.
Having spent about 30-40 years in IIT as a professor and having guided so many projects on this stainless steel, I feel like saying
very
a few words.
privileged. Our topic has attracted Dr. Prasad.
Actually, I was not knowing that you are coming for this conference.
Okay,
I saw
okay,
it
please
in
go
Times
ahead
of
with your-
India
please go ahead
yesterday,
with your comments.
and I thought I must attend this conference.
Good, very
First
good
of
of you.
all, I pay a lot of things. You must have attended several NACE conferences abroad in USA. I was, first of all, I am impressed by this geo center itself. It is comparable to any other center that I have seen in USA.
Good,
you know?
very good.
So that was my first, I had seen it from outside and it was my first choice that when I entered this center, and today it gave me an opportunity. So first of all, second thing about stainless steel. I think Dr. Tanki may remember 10 years back,
Yeah, sure.
we celebrated, I think, centenary celebrations of
Yes,
stainless
yes.
steel in Delhi. And there was a big fanfare. So we are 100 years old. And you know, the question is, I'm not here to discuss what problems or failures happen. Because everybody knows that the cost of failure, as we have estimated, is about 4 to 5% of the GDP of any nation. So definitely failures are important. But the question is, what are the new concepts that are developing? And how we can sort it out. For example, Dr. Tanki was talking about welding. Now you know that several codal requirements are there. They were talking about stress corrosion cracking, corrosion fatigue. Many of the tests are based on simple tensile tests in corrosive medium. But now
Dr.
you know,
Prasad, can you be a little more specific? We will come to some specific questions answer.
yeah,
Yeah,
I'm
sure,
telling-
please.
I'm only telling that in our country, for specific evaluation of this, using fracture mechanics concepts are not existing even now. We are following the same old pattern. Second thing, when you are talking of welding, all the industries you know here are smarter. They are adopting welding 4.0. So the welder you know has given all his knowledge and the robots do the whole thing. And in any industry, you know, yeah, I mean, of course, welder's qualification is important, So there are change in scenario. And this stainless steel is not welded, I mean, first of all, you have to make a stainless steel. So forging is one of the major problems. So how do you do that? In India, we have GLOBEL systems. You have to establish the temperature at which you have to pour. So what I mean is that you have to have simulation of these processes, and we should go for digitization more than depending on individual skills. And last, we are all old. Industries, they don't bother about the academic institutions. Who is going to shape the face of this nation? After all, the students. So kindly interact with the students. Let me tell you, after retirement,
It's a good advice.
for the last 7 years, I would have joined any IIT as a visiting professor or anything, but I prefer to join a private college, and I'm trying to train the 10 lakh or 15 lakhs engineers, who are coming out of this engineering college. So please pay attention to us also. Thank you very much.
Thank you, Dr. Prasad. I'm sorry. Okay. Yes, somebody asked. Please feel free. Let it be any type of question.
सो सर या जैसा सर ने बोला कि बेसिकली हम स्टेनलेस स्टील को एज ए कार्बन स्टील की तरह ट्रीट करते हैं
Right.
लाइक सिलेक्शन लाइक इन टर्म ऑफ गैसेस सो बहुत सारी कंपनी जो एग्जॉस्ट मैन्युफैक्चरिंग करती हैं स्टेनलेस स्टील द ग्रेड इज़ 308L एंड दे आर यूजिंग 80% argon 20% CO2 बट अकॉर्डिंग टू मी राइट गैस इज 97.5% argon 2.5% CO2 और 98 or 2% O2. Right, so we need to increase bed properties also, right? So what is your take on 80-20 for stainless steel 308 grade?
Metallurgy, sir, metallurgy.
Say that question again.
Basically in automotive industries, basically in Japanese companies are using 80% argon, 20% CO2 gas
Yes.
for especially for 308 grade of stainless steel material.
Right.
But according to us,
Yeah.
the right gas is like 97.5% argon or 2.5% CO2 or 98 or 2% O2. Right. So what is your take on 80% argon, 20% CO2?
Okay.
Related to
there is
corrosion,
a-
yeah.
There is a major difference between duplex stainless steel and the steels used in automobile industry. There is a class called ferritic and martensitic stainless steel. Their welding characteristics are somewhat different. So they use this because it's easy to make sort of a small size bends and fenders and also fittings. So in that case, welding is somewhat different. So you must go through the welding handbook and look for, go to Google and look for ferritic stainless steel welding, austenitic stainless steel welding, and martensitic stainless steel welding. Then you will get your answer there.
Okay. Generally in especially
Plus,
for
automobile finishes are also important.
Yeah.
Finishes is not that important in process industry.
yeah, because basically in stainless steel we need to control the heat input. Heat input is a very, very important.
Right.
Right. So when we add the active gases like CO2 and like other active gases in a more percentage, more than 5%. So maybe like carbide formation will be more. Right. So maybe corrosion chances will be more. But still some industries are using 80-20. And we will able to easily find out the blackish weld bead. Right, sir? So yeah, thank you, sir. So a lot of awareness is required basically like when stainless steel come into the picture in terms of welding. Yeah, thank you, sir.
Automobile industry specifically focuses of using thin material, lighter material, because the fuel efficiency is important. Keep the weight. In that respect, stainless steel little slow as compared to, because the strength is high. Yes, you hold on the mic.
I learned from you that what type of gas I should use. I'm not a specialist in welding. Yeah, but no, you are correct. What you said is that it may lead to carbide. Yeah, that may be the reason. I can cite one example. There are many auto manufacturers. I don't know whether I should name or not. One of the leading Toyota. This exhaust system, they are making of stainless steel. And what happens? The gases temperature is around 800 because now we are going to Bharat 4 or something like that.
That is the reason high chromium stainless steel.
So what happens is sensitization is one of the major problems. And you know, many car manufacturers, they have not heard even anything about sensitization. So that is a good thing for us. They call us, oh, do you know what is sensitization? We go to them and tell, oh, look here, what is sensitization, how we can avoid it. So those are some of the problems, you know, which we must interact and solve it.
Thank you, Dr. Prasad. Somebody else has got a question, I think. I saw somebody raising a hand. Please feel free. Yeah, sure.
It seems from you people, either you have got understood everything fine. So there you are not raising any question. Or you do not consider that this audience will not be answering you. I think these are the two ways only. They understood totally. That's why they are not questioning. Right, sir?
Yes. SS 201 में हेलो SS 201 वेल्डिंग में आर्गन परसेंटेज क्या होना चाहिए वेल्डिंग के लिए?
Say that again.
201 SS.
I'm not able to keep the mic close by.
Yes. SS 201.
I would request the
for
gentleman.
welding SS 201 sheet metal.
Yeah. You are asking about future potential of 201.
Yes.
Yeah, I'll tell you the background of this 200 series stainless steel. Because if you are in the marketing, if you are in the sales, if you follow the stainless steel pricing always follows the nickel pricing. The nickel is the most important price dominant element. And also it's the most expensive element compared to chromium. Even though the chromium is much higher level. So the lot of work went on, even now it's still going on, substitution material for nickel. And manganese is other element. We have got a lot of ferroalloys in our country, not ferro-nickel, but ferro-manganese, ferro-chrome. So manganese is supposed to be a substitution element. That's why the 200 series have been developed. And where in the place of nickel, some 3 to 4% manganese. And Steel Authority have done a lot of work on this, and they also compared the mechanical properties, and so they have come out with very good specifications. You can use 200 series. Probably if you have faced any problem which is respect to 200 series, not much of it is not as corrosion resistant as 300 series, but still for mild application you can very much use. There are a lot of kitchen utensils also come under 200 series. Yeah, your question is?
My question is, what type of techniques for welding 201 material, and we observe the black strips after welding, or some fractures observed after?
We will give you certain specifications. Just leave your contact.
Okay.
There are very good specifications which deal with 200 series welding characteristics.
And we observe 5 to 10% rejections percentage.
No, it's very difficult to comment now.
Oh.
It is come to a level of suitability for kitchen vessels. I mean, so to that extent it is successful. We will go. There are still specifications. We will be able to give you the details. Okay. Please make sure you give us your contact numbers.
All right, so any closing comments from Dr. G.H. Tanki?
Instead of any comments, I have got the observation that so I was not expecting that many participants will be here. Naturally so. You wouldn't wonder people have got attracted over here to listen. And I believe so that whatever the presentation will be made by us, it has made you aware one thing. Stainless steel by itself is a raw material, raw sheet, rods like that is not going to make any difficulty to you. But when you are going to fabricate it by any means, at the time if you have overruled the basic requirement of the welding and such parameters, naturally it will give you a lot of problems to you. So be careful while fabricating the vessel, follow the guidelines given by the fabricator, because fabricator knows its baby when it is in good mood or when it cries. So you should know welding characteristic given by the manufacture. That is what I say from my experience I'm telling you. Because that had given us our this particular ammonium chloride duct. Total it was costing somewhere 8 to 10 crore rupees. When it got downtime, we lost production. We had worry about a certain escapement will take place of high temperature gases, but we could tide over because of we followed the conditions. So this is the only awareness that will bring you more wise in case, sir. I think that is the only thing I can say. Yeah.
One just a final comment I would like to make. I thought whether it is missed or anything, without mentioning any companies, very big companies in the world, including India, they do work on carbon steel, they do work on stainless steel. But they have a separate bay for carbon steel and separate bay for stainless steel. They don't mix each other. Even a one splash of welding spot going and carbon steel to falling on stainless steel, that location is no more stainless steel. Similarly, the other way, stainless steel flashing on carbon steel, again, that will weaken the. So it is absolutely important that stainless steel work should not be contaminated with carbon steel. Thank you very much.
Sir, we have to immediately start with the next session. So sorry, sir. Sir, आपके साथ नीचे ही मौजूद होंगे. आप डिस्कस भी कर पाएंगे इनसे काफ़ी कुछ. So we'll have to move forward to the next session. So sorry, sir. So, check. Lady and gentlemen, I would just say. So we had a presentation and case study. We had a presentation where we spoke about wrong choices, ammonia plant, urea plant, fish mouth failure, crackings, chemical analysis. Along with that, we spoke about carbon foot, cutting down the carbon foot. Stainless steel is 100% reusable. 5 mistakes, responsibilities of welder and supervisor, and many more important details. So with this, we come to an end to our very first session of the day. I have a quote, if I can share with your permission. Simple quote. So winners are not born. They rise from the ashes of failure. Those who outstay the failures will become winners. So this was our session. Wonderful. Thank you so much, both the gentlemen. Now I request Mr. Raghunath, MD, Virgo Communications and Exhibition, to please step up on stage and present a memento. The first memento to be presented to Dr. Ilaya Perumal K. Ladies and gentlemen, can we put our hands together? Followed by Dr. G.H. Tanki. So I can't tell you how special this session was. Gentlemen, those who are having experience of more than 45 years, coming here and sharing it and being in the industry and going rock solid is something amazing. So can we once again hear it for both the gentlemen, ladies and gentlemen? Thank you. Thank you, Raghunathan, sir. And we will begin with the next session now. Thank you. ब्रेक का बिल्कुल टाइम नहीं है. आप में से कोई भी जाए नहीं. हम नेक्स्ट सेशन अभी शुरू कर रहे हैं. Ladies and gentlemen, we are starting up with the next session, session 2 of the day. And the topic for this one is powering railways and surface transportation in India. Ladies and gentlemen, we are about to begin. Can we please increase the mic volume? ये वाला mic का volume बढ़ा देंगे. Check. Dear attendees and guests, we are about to begin with the session 2 of the day. There's no break. We are starting it right now in 2 minutes. So I request all our guests and attendees to be assembled in the conference hall. And the topic for session 2 is powering railway and surface transportation in India. We have a wonderful panelist and moderator who is all set to educate us about the topic. So I request all our guests and attendees to be assembled in the conference hall. Thank you. check. Good afternoon, gentlemen. We are about to begin with session 2 of day 3. I request all our guests and attendees to be assembled. Check. Volume karna, please. Hello, check. So, lady and gentlemen, I think we should begin with session 2 of day 3. I would request all of you all like to come forward and occupy the front row seats. The gentleman who's shining in blue right there, I would request you also to please come forward and be a part of this session. आपसे भी हम आग्रह करेंगे सर, प्लीज आगे आ जाए. Thank you. Fantastic. So here we begin with the session 2 of our day 3. The topic is very interesting and so relatable to each one of you. The topic is powering railway and surface transportation in India. So to begin with, I would like to invite the moderator of our session. So I invite on stage Mr. Lalit Chandra Tiwari, GM Rail Infrastructure Expert. Now I would like to invite the panelists of the session, starting with Mr. Anantha Reddy, Chairman, Mazes Kartikeya Industries. Mr. Harsh Dhingra, former Chief Country Representative, Bombardier Transportations. Lastly, Mr. Anil Kumar Lahoti, GM, Central Railways. Pleased to have you, gentlemen, all of you all. We're thankful that you took out time from your busy schedules for this session and educate us. Now I hand over mic to the moderator, Mr. Lalit Chandra Trivedi.
Good morning, everybody present here. First of all, I will like to thank organizers for this symposium and for this panel discussion and for this grand expo which we are seeing here. They have done a wonderful job. The stalls are excellent and they really give a glimpse in various areas what stainless steel can do. I am L.C. Trivedi. I retired as General Manager from Indian Railways and presently I am Chairman of Rail Division of Institute of Mechanical Engineers, India, with headquarters at London. I have spent about 40 years in the railways and other infrastructure industries like power plant. I started with NTPC and then spent 38 years in railways. Railways has taken me to various places from Mumbai Suburban, Chennai Indian Integral Coach Factory, to Assam, Chhattisgarh, and ultimately Bihar, Jharkhand and other regions of the country. I have been associated with railway, various facets of railway operations and manufacturing, production, procurement and other areas, and it was a really fantastic journey. Today it's a coincidence that railway industry all over the world, whether metros in the surface transportation or railways for long distance, medium distance, are showing resurgence because of the climatical regions. as you may be aware, that the energy consumed by railways is 1/7 of that of road transport and 1/15 of that of corresponding air transport. So for ecological reasons, in fact, countries like France have discontinued flights officially between some cities where the rail journeys can be performed within 5 to 6 hours, and many such many other European countries and Western countries and developed countries are taking this step to discourage air travel between the cities, which can be easily commuted by railways. As a result, and in fact, Government of India also wants that the share of rail transport in the overall kitty of transport throughput which is there in the country, today the railway share is about 30%. The target is to take it up to 45%, mainly because of the environmental consideration and for the economy of scale. And you must have read in the newspapers that recently a lot of traffic has come to Indian Railways because of our switching over to electrification and lesser dependence on imported diesel oil, which is the price of which has skyrocketed, and people are finding it cheaper to move their goods by railways and travel by train, mainly because the economy of scale and economy of per unit transport throughput. Again, it's my good fortune that today I personally know all the three panelists. I'll start with Mr. Reddy. Mr. Reddy is basically a metallurgist who started his career with HAL, Pennar, and so many other industries. And in mid 2015, around that time, he started his own venture, Kartikeya Steel Industry. And within a short period of time, he has become a major supplier to railways. It was my, again, fortune that during my tenureship as chief mechanical engineer in the ICE integral coach factory, we gave him the status of developmental source. And today he has become the major supplier, not only to ICF, but to MCF, RCF, and so many other industries. In fact, he is also associated with constructing few stations on the high-speed corridor of Ahmedabad, Mumbai. He is an expert on cold forming. His ideas have resulted in weight reduction, tear weight reduction of wagons, and his group, Kartikeya Group, has registered a compounded annual growth of 60% for last few years. It's a credit to him that the steel industry, stainless steel industry, he has a lot of things to offer to them. And we hope that today when he speak about the subject, we all will be benefited. Thank you, Mr. Reddy. Gentleman sitting next to me is Mr. Anil Lahoti, who is presently General Manager of Central and Western Railway both. The suburban system of Mumbai is today, he is at the helm of the affairs. Basically, he is a civil engineer and one of the recognized faces as the leader in infrastructure building in Indian Railways. New Delhi Station, Anand Vihar Terminal were conceptualized, their development on PPP basis he was at the helm of the affairs. He has been responsible for multi-tracking project, various railway infrastructure projects, and presently in his current duties as General Manager Central Railway, almost all the records of performance have been smashed, whether it's the freight loading or non-fare revenue collection, parcel loading, and he conducted the railways, he spearheaded this railway in an excellent manner during the COVID period, and he will get a lot of glimpse about his contribution to the railways and to the infrastructure industry in general. He has done his structures, post-graduation structures from Roorkee Engineering College, and his credentials are almost the best in the country in the field of infrastructure today. Thank you, Mr. Lahoti. Our next panelist is Mr. Dhingra. He is presently a railway consultant. He is the man who is associated with almost all the metro systems, most of the important metro systems in the country. And his advice is taken at the highest level in government for any railway project. He started his career with Crompton Greaves and then Mitsubishi and then Bombardier. In fact, he was country head of Bombardier. He was on the board of directors of Bombardiers. He also headed Indo-Canadian Chambers of Business for few years. And today also he is leading an active life. And we have been, in fact, when I was principal chief mechanical engineer in ICF, we made suburban rakes for Mumbai suburban system. And that time, the propulsion system for these rakes was supplied by Bombardier, which was at the time was headed by Mr. Dhingra. He is basically an electrical engineer with a post-graduation degree in management from Delhi University, and a known railway and metro expert in the country today, who everybody looks up to if there is any issue connected with these systems. So without wasting much time, I'll start with Mr. Dhingra, and there are new challenges being thrown up in railway sector, metro sector, PPP things, and in fact he is associated with the regional rail transport system of Ghaziabad, Delhi also, and we have a lot to learn, and listening to Mr. Dhingra we'll all enjoy listening to him, and we'll gain something out of his vast experience of almost 38 years. So, Mr. Dhingra, please.
Thank you. Thank you, Mr. Trivedi. And thank you, my other panelists, to be on this panel today. Well, you have asked a very specific question on how the metro and rail market is currently growing in India. As a person who is coming from private industry, I will say I am bullish about it, because both metro and rail sector is growing over the last 15 years. Because earlier I was a component and system supplier to railways. For the last 15 years I have been associated with railways or the metro as a supplier for the complete coaches, as well as for the supplier for the complete signaling system. So I have seen the growth which is there in the last 10-15 years, especially in the rolling stock industry. And the advantage that we see today, especially when the government of India has invited the private players to get into the manufacturing of the rolling stock. Earlier Indian Railways directly were manufacturing the rolling stock, but in the coming days they are coming with a big requirement of the private sector also manufacturing the railway coaches, which I think is a good potential for the industry. And secondly, I would say that as a component supplier, majority of the industry who are supplied to railways, they must have seen the double-digit growth in the last 5-6 years. Especially when we have seen that the coach production and loco production has gone up in railways, whether it is CLW or Banaras Locomotive Work or ICF, RCF. So majority of the component supplier have seen a real growth on the revenue side as well as the profitability. So from industry perspective, I maintain that I am bullish about it. On the metro segment also, we have seen a good pickup in the last 6-7 years. Though I would say that in the last 1 or 2 years, there has been a slowdown. And the slowdown is, I think, primarily driven by the major city, which is Mumbai, because Mumbai is not expanding the way they should have expanded on the metro segment. Whereas all the metros, whether it is Delhi, Bangalore, Calcutta, or Chennai, they have expanded. Delhi almost touching 400 kilometers. But Mumbai has not expanded the way we thought that we will expand in the last 4-5 years. So I'm still bullish, but I still maintain that the metro coach production will remain stagnant for the next 5-6 years unless we see a huge demand coming from Mumbai side. And all the players who are in the rolling stock industry and the supplier to the rolling stock industry, especially the steel supplier, because this particular forum is for the stainless steel, I would say that there is an opportunity for the suppliers of the stainless steel, for the coach as well as for the railways, to be in the next 7 years to remain as a bullish. And next point which I just wanted to touch about it is about the possibility of more private participation. Unfortunately, Indian Railways have tried, metro organization also have tried private participation in the rail and metro, but I don't think any private players is coming forward to take the risk of the traffic. So that is the reason majority of the private participation through the PPP have failed. Unless now the government comes out with a revised kind of a policy to make the private player real partner with a traffic sharing risk, I think PPP may not work in India. So these are my initial comments, and maybe in the course of our discussion today, I would like to touch upon two critical topics. One is on the stainless steels versus aluminium, because there is a lot of debate which is going on, and also that what kind of market stainless steel companies can see in the coming days. So these are my initial comments. I thought let me start with.
Thank you, Mr. Dhingra. I'm sure that we'll benefit by your ideas and your views on the subject. Mr. Lahoti, as I said, that has one of the infrastructure expert of Indian Railways and currently heading Central Railway. The capex of Indian Railways this year is 2,32,000 crores of rupees, which is the highest ever capex in the history of Indian Railways, and major part of it's going for the construction of new railway lines. We will be manufacturing almost, we are targeting to manufacture almost 8,000 coaches, all made of stainless steel. We will be making more than 1,000 locomotives, and last year we laid about 3,000 kilometers of track and bridges, and recently for a path-breaking decision, Indian Railways floated a tender for 90,000 wagons, 30,000 for each every year for next 3 years for 35,000 crore. And there is another tender for Vande Bharat Express. There are procurement process for the 200 rakes for the Mumbai Suburban. Apart from the new lines, gas conversion, multi-tracking, bullet train project, and so many other areas where the railways are expanding, I would request Mr. Lahoti, with his vast knowledge of this area, and he has been at the center helm affair for a long time in Delhi, to throw light on these subjects, on the capex program of the railways and what is there in the pipeline for the industry as a whole.
Thank you, sir. As Mr. Trivedi has already introduced me, I am a civil engineer, and I have been working with Indian Railways for almost 36 years now, mostly as a civil engineer in different capacities, and I have been associated with construction projects as well as the maintenance of track and mechanization of track maintenance. So, as Mr. Trivedi said, this year Indian Railways have done nearly 2,900 kilometers of new line doubling and gauge conversion projects, and the government has given 2.35 lakh crore for the current financial year for the infrastructure. Significantly, this includes almost 1.35 lakh crore of budgetary support, which is the highest so far, and there is a significant jump from the previous financial year in the budgetary support, and the indications are that that the government is going to even further support Indian Railways in terms of the budgetary support. So what had been the always the problem that railway was looking for financial support, that age is over, and for last few financial years we are getting very good budgetary support, and for the current financial year, in fact the target, the plan is to do more than 5,000 kilometers of new line doubling gauge conversion in the country. So significant growth in terms of infrastructure projects is planned, and this year Indian Railways have loaded more than 1400 million tons of freight, which is expected to be almost 28% of the total freight carried. So there is a increase in the railway share as compared to the past. From the 26%, now it is increasing, and the target, as Mr. Trivedi said, is to reach 45%, and the aim of Indian Railways is to reach 3000 million tons of freight traffic in the near term. So with that objective, infrastructure augmentation is being carried out, and the government is very positive about it. So that is one thing which is happening in railway. The second thing is about the station development. So station development we have been talking about for a long time. So now already 2 station development projects have been commissioned in the recent past, that is at Gandhinagar and the other one at the Habibganj. So with that, the beginning has been made, and now a large number of station development projects are now coming in the execution phase. So shortly, like the big ticket projects are New Delhi and Chhatrapati Shivaji Maharaj Terminus of Mumbai, where the bids are likely to be invited shortly. And now the government has also decided to go on EPC mode for the construction of the station proper and take up the commercial development as a separate project subsequently, instead of going for purely PPP model where the developer finances the station development. So that is another thing happening. And in terms of the rolling stock side, already Mr. Trivedi has mentioned that we have the plans of Vande Bharat type of trains, both production within the railway production units and also planning for tender for manufacturing by private partners. And also we are, Indian Railway has already decided to go completely for the LHB type of coaches, and also the BCN HL and Boxen HL type of wagons, both of which substantially use stainless steel in their manufacturing for the longevity and lesser weight, and so better productivity. So these are some of the broad contours, I would say, regarding the railway sector. So tremendous growth potential in railways. Thank you, sir.
Thank you, Mr. Lahoti. As he says that the goal is to reach 3,000 million tons and to have and you just can imagine the capex limit which it will require to reach that goal. We have a large number of station development projects also on the anvil. Apart from, as he said, that this year's target is 5,000 kilometers of new track, which is something was beyond imagination. In fact, just to give you an example, when I joined railways in 1983, that time the annual loading of railways used to be 200 million tons. And today, the incremental growth from the 2021 to 21-22 is more than 200 million tons. So that is the figure that you just to conceptualize. Now, gentlemen, I would request Mr. Anant Reddy, who has been instrumental in many technical innovations in the industry, particularly rolling stock. He was instrumental in reducing the weight of the stainless steel wagons. In fact, my previous speaker, he spoke about the enmity between carbon steel and the stainless steel. In fact, we are still in the LHB coach, which is our stainless steel coach. We have underframe made of carbon steel, and that superstructure is of stainless steel. So we are trying from the industry another point of view to have both the things from the stainless steel, so that this problem between the two, I would like Mr. Reddy to share his views that why we should expedite it. And that's okay. And number two, one more thing which, while in case of the LHB coaches, when we switched over to stainless steel, from ICF coaches were all cotton steel, and then we switched over to LHB coaches. The life of the coach, quarter life of the coach was increased from 25 to 35 years. But when we converted our wagons from cotton steel to carbon steel to stainless steel, the life continued to remain the same. So whether the quarter life increase which took place in case of LHB coaches should have been undertaken in case of stainless steel wagons also, that I would like Mr. Reddy, apart from first how he has grown up, his commercial success of having achieved in an industry like steel industry to in a steel industry, in computers and Zomato type of companies, you can have 60% growth, but to achieve 60% growth compounded for few years in steel industry, stainless steel industry is really something we must learn, all need to learn from Mr. Reddy, how he achieved it, and his ideas of how to improve the sector, what are the challenges this stainless steel. In fact, he was telling me that he is finding difficult to get stainless steel for last 2 months. So other challenges which are there in the which the industry is facing, I would request him to elaborate upon. Mr. Reddy.
Thank you, sir, for your introduction. So, I am working in the industry continuously for the last 52 years, sir. I started my career as a lecturer in JNTU, Hyderabad. That was a very short period. Afterwards, I worked in Hindustan Aeronautics Limited. I was working in forging and casting industry. From there, I moved to Nagarjuna Steels, which was a flat products division. And I continued there. I was the managing director from almost for the last 15 years there. At the age of 67, I retired from Pennar Industries as the managing director and vice chairman. I started this new industry at the age of 67, sir. In the year 2014, actually Trivedi Sahab has not forgot to mention this Train 18, which is a revolutionary project in India. He is the brainchild of him. He is never telling about that. Because I am the first-hand information. In fact, in the 2009 and 10, or 8 and 9, I don't remember, RCF was producing these LHB coaches, the stainless steel coaches, and they spent huge money for bringing the technology from Germany. And that time, the ICF requested us, new vendors. But Pennar was one of the good vendors for that time, because we started supplying the cold form profiles to the ICF right from 2001, 2002, I remember. Because we have developed already the profiles required, especially the underframe stainless steel profile, and then soul bar, cantrail, 4 5 complicated items. Either two was manufactured by assembly in ICF, was developed through profile. And that's how we are associated. I am associated for the last 22 years with the Indian Railways by supplying profiles in a small way. And 2008, they invited us to come for a conference there in ICF, sir. That time you were there, sir, 2008? Yeah. That member mechanical one, Mr. Ram came. Yes. He requested us, why don't you just go, ICF also should do by copying RCF, not by any these things. So they requested us, you go and see anything, copy those jigs, fixtures, whatever is there. So we were given free hand. We have posted some few people there in RCF. We just copied it, nothing great. I'm telling you, sorry. They just spent huge money, and there was no work culture. Sorry, RCF, somebody is hurt. But there was absolutely no work culture there. They were producing hardly 100, 200. Whereas work culture at ICF and the management ICF was also superior, I feel, even today. They just quickly developed vendors. There are a lot of vendors developed now. More than 10 people are there who can supply stainless steel vendors. It is not a big, great science or anything like that. It's only just attitude. So now a lot of ICF has developed more than 10 vendors. If you want 5,000 coaches of LHB ICF can produce. Because that much vendor support is there. And quality vendors are there. Of course, before I entered, I am the latest entry. Actually, I started, I think, 2016. Trivedi Saab somehow learned about my as an individual, because my previous company was Pennar Industries. There I was almost like a single man running the company from scratches to riches there. So after retirement, I started this company, and there was a lot of counter pressure on me from my previous company how to not start this company. I am very grateful to Trivedi Saab. Actually, I have not met him any time. Only first time I met, he asked me, he said probably he heard about me through some other source, I don't know. He was a big man, no? Yeah, CME is a big post there. He was almost like head of the plant. It's very difficult to get interview. I just gave one request letter. Said that, Mr. Reddy, don't talk anything about you or your company. I know about you. What do you want from me? He just asked one question. I am busy. Sir, I want to be regularized. You are the most deserved candidate to be regularized. He just 2 minutes, he just scratched and told Srinivas, his assistant, CD Mech, saying that immediately approve him. Because there are a lot of counter forces on me working there. You know, the Indian Railways, how it works. But he was so great man. He was working on Train 18, and he gave us some work on Train 18 also for us. Within 5 minutes it was approved. Because approval process in railways, you know, is a long drawn and so many problems. So he is such a great person. So to honor him, I came here actually. He was so simple man, no? He just went by merit. Because I supplied very short period. Within 1 year, I developed all the LHB coaches. Because I knew most of the things, because earlier I had associated with that. And in 2008, RDSO was working seriously on how to modernize the coaches, the wagons, sorry. Wagons were all doing conventionally mild steel, underframe and side walls, everything. So I associated myself with that project because we were experts in profiling. I have a lot of experience. In fact, that time I built one profiling machine which can do 10 mm profiles of top hat, which is the major backbone of the wagon. And by developing those profiles, that profile is 10 mm stainless steel, single piece 1 ton. It was unheard. Normally profiles are all 100 kgs, 200 kgs, 500 kgs, maximum 200 kgs. Even if you see underframe, the whole of underframe is how much? Just is 1 ton, which will be, you know, having some 6-7 pieces together welded. But whereas for the wagon, we have developed 10 mm profile of single piece 1 ton. That machine was weighing around 200 tons. I developed that machine, and imported machine was requiring 2 years' time. They wanted very short. I designed the whole thing with my team and produced those products within 6 months. And whole country's requirement of 2009, I supplied 90% of the requirement myself. In fact, because of that, my company turnover went suddenly from 900 to 1200 crores in 1 year, sir. And the major contribution was this wagon. So we also gained heavily, and the country also gained heavily. All that wagons now also working. In fact, I got your report, sir. They are doing wonderfully well. But we should continue to do more and more stainless steel, because it has got high wear resistance, high corrosion resistance. What more you require? And the payload has gone up by 1.5 ton. Tear weight reduced by 1.5 ton. That means you are continuously carrying 1.5 ton more material for every trip. You are gaining 1.5 ton. In fact, in your calculations, there is no gain on the carrying extra weight. Instead of 24 tons, you are carrying 25 tons at no extra cost. That means railways are continuously earning 1.5 ton extra, that freight charges, for the same amount of energy spent on carrying this product or same wagons. So the payload has gone up, your revenues have gone up, maintenance cost has come down. In fact, it has to be quantified in that direction also. So like that, we can do a lot more. Because the RDSO has got a lot of impediments, a lot of limitations, because they don't have full-fledged design, sir. They have more authority. But more than authority, you need some brain input. How to reduce the weight further? You can see this Bombardier. I worked up with Bombardier products also. Sir, what we are making, these sidewalls for stainless steel, today for coaches, it was made 2 mm to 3 mm. I don't know whether you remember, sir. I have given a challenge to you, saying that I will supply with 2 mm, with same that 3 mm undulation or whatever. They were more perturbed with undulation. I said I will stretch that product in making while making itself, and see that with 2 mm itself, because any weight reduction is going to be a tremendous advantage to the life cycle of that product and the cost, because as you have mentioned, energy is the most important. Because if you are got carrying the dead weight of that coach, you are spending so much of money on carrying that. The same dead weight is reduced, and if the passengers are increased, your revenues will go up, the cost will be same. So today also, because of that sidewall undulation, you have increased, whereas MCF and RCF, they stuck to that 2 mm. We manufacture same coaches for MCF and RCF with 2 mm, whereas ICF is still that old that concept. Mr. Mani was so particular about that undulation. Undulation can be reduced by stretching. I gave a letter to you that time itself, almost 5-6 years back when you were there, or maybe to your successor, Shubhranshu. I said I will stretch the skin, I will reduce the weight. But that itself is 1 ton of coach. Against the coach weight of, I think now, around 20 tons, 18 tons, something like that. We will reduce 1 ton only just by reducing the sidewall. They were more particular. If you see the metro coaches, they are all undulation only. Metro coaches, you look only undulations, but beautiful. You see, now you see all the metros, but nobody will comment on that because it is imported. हमारा देश का तो undulation है, थोड़ा ये टेढ़ा के दिख रहे. That doesn't have any practical this thing. So I request you are in power, sir. You please take up with railways. Why we can't convert this 3 mm to 2 mm sidewalls? We'll reduce the weight. Today the cost of stainless steel is going up every day. And moreover, energy cost is phenomenal. How to reduce the weight? So we need the railways also. So there are a lot of changes taking place, but still it is not proportional to the world, sir. Your progress has to be much faster. How is the world is moving, how we are moving. We are still moving at snail pace.
Thank you, Mr. Reddy, for coming out. So, Mr. Lahoti wants to comment on.
Sir, I beg to differ. We are not moving at snail's pace. Our volumes are very, very high. No railway system in the world compares to our volumes. And we are the lifeline of the country. So every change is made with proper thinking and thought. It's a huge system. So changes are taking place, and changes are taking place very fast. So there I beg to differ.
Just to give an example of how fast we are changing, when I took over as CME in ICF in 2014, we were producing, there was nil production of LHB coaches, no nil consumption of stainless steel, nothing. They were only producing carbon steel coaches. And then I set up that factory and for the stainless steel manufacturing, and RCF used to be the only factory which was making LHB coaches, and they used to say that 1,000, we just cannot produce more than 1,000 coaches. And if you want more, you employ more people and all that. I was made chief project manager for this project of high-speed LHB project, and within 2 to 3 years, RCF was left behind, and we started manufacturing 4,000 coaches, 4 times the number of coaches which RCF was manufacturing. And in the same case, in the local trains for the Bombay, Mr. Dhingra was helpful in supplying us with propulsion system, and we could supply almost at the rate of 10 rakes to Mumbai's suburban system every month. And today you can see that otherwise most of the coaches in Mumbai suburban system had outlived their quarter life, and there was a point of collapse. And that time we entered. Now I would request Mr. Dhingra to touch upon other subjects which he is expert on.
Well, I will just supplement to what Mr. Reddy said. I will just give you a very good example here. Train 18, which was developed by ICF, was a prototype train. And it has come out to be a very good train. But still, I would say there are a lot of design modification on the weight reduction which is possible on train 18. And Mr. Reddy rightly said, unless you do the design modification, you will not be able to achieve it. And I will give you an example here. Today, train 18, which is called a 160 kmph train, has a tier load of about 15.5 to 16 ton per axle. And just imagine, in my earlier company, Bombardier, we developed a train for RRTS, which is Delhi Meerut, again 160 kmph, though standard gauge, but the width is same, it's about 3.15 or 3.2 meter. There the tier weight is 11.5 ton, same stainless steel. So from 15.5 ton of train 18, Bombardier was able to deliver at 11.5 ton, which is a 4 ton per axle we were able to reduce. So there is a huge possibility, like he said, on the car body, on the underframe, and also on the weight optimization on the propulsion side, where we are able to reduce the weight. So there is a huge challenge. I would say that I will give full compliment to railways for having developed train 18 as a prototype. Now next train 18 which is coming, which we call it Vande Bharat 2 or Vande Bharat 3, their railways themselves are saying we would like to have a tier weight of 12 ton or 11.5 ton. So 4 ton per axle reduction on a train which is running at 160 kmph, you can imagine the kind of energy saving we are going to have. So this is the example I just want to share, because you have delivered that in wagon. This can also be delivered in the coaches, which is practically possible. Then one more topic I thought, let me just address here, because this is a stainless steel community sitting here. But over the last 2 decades, internationally people have shifted to aluminum on the car body material. Whether it is advantage to shift to aluminum or not, that's a debate that will continue even today. It will continue for the next 2 decades as well. But if I give you the historical perspective on what is happening on the aluminum side here, today majority of the world countries have shifted to aluminum. I will give you example country-wise. Europe, almost 80% of the current production is aluminum coaches. Whether it is the intercity trains, whether it is regional trains or high-speed trains, all aluminum. 20% still for the metro activity or for the local network goes with the stainless steel, but they have shifted to aluminum in the Europe. In USA, being USA, they have continued with the stainless steel, and almost 80% to 90% is stainless steel, only 10% is the aluminum. You go to Japan, again 80% is aluminum, 20% is stainless steel. You go to China, 90% is aluminum and 10% is stainless steel. And if you see the worldwide manufacturer also, today, who are the leaders? Leader is today CRRC, Chinese player. 95% of production of CRRC today, because they are focusing more on the speed, is aluminum. If you go to Alstom, almost 80% of the current production is aluminum worldwide. I am not talking about India. Worldwide is aluminum. You go to Stadler, 100% aluminum. You go to Talgo, 100% aluminum. You go to CAV, 100% aluminum. Almost 95% aluminum, I would say. But what is driving that people to shift towards aluminum, and in India we are not able to do? 3 reasons. Availability of aluminum material, aluminum extrusions which are required, because the car body length is about 22 meters to 25 meters. These are not available, and the price. And also the welding technology which is required in the case of aluminum, which is not available in India today. So for the friends who are from the stainless steel industry, I would say in India, still the stainless steel will continue for the next 20 years. I don't see stainless steel, aluminum changing to stainless steel. The worldwide people have changed, but I don't see it is happening till the time volume comes. And if we are able to reduce the axle load, because why people in Europe and China and Japan are able to shift to the aluminum, it is mainly because they are increasing the speed level. If I see the speed levels of the trains, the moment it is 160 kilometers per hour in the intercity, you have axle load of almost like 21 ton per axle. The moment you go to 200 kilometers per hour, it touches almost 17 ton. And if it is 350 kilometers, it is 12.5 ton. I don't think in the stainless steel it is possible to reach 12.5 ton for 350 kilometers per hour, especially with the weight consideration and energy consideration, as well as the acceleration requirement for the high speed. So there, unless we go to the high speed of 250 kmph and 350 kmph, which will happen, but not in this decade, maybe the next decade, aluminum requirement will be there. Today, dependence on aluminum on imports, 100% imports, will make the car body prices very high. And just to give you an example, car body constitute almost 25% of the total weight of the train. And changing from stainless steel to aluminum, we can reduce the car body weight by 30%. And overall impact on the total tare weight of the train is almost like 5%, because I said 25% is the car body. Now energy saving because of this 5% reduction is almost 5 to 7% depending on which speed you're working. So on the life cycle cost, aluminum is beneficial. Aluminum definitely is beneficial on the life cycle cost for the high speed. High speed, when I say, I talk about 160, 200, 250 and 300. Today India is not there. So from the stainless steel perspective, I still feel from India point of view, this trend will continue. LHB will continue. The new Vande Bharat trains which Government of India is coming out, they are giving an option of stainless steel and aluminum, but I still, industry is still not ready in India to manufacture aluminum, because if you have to manufacture the train in India, you have to have aluminum sourcing from India, aluminum extrusions, aluminum car body material. Japanese have gone for the double skin type of aluminum. These things are not available in India. So companies who are there in the aluminum industry like Hindalco, you have Nalco, you have Jindal also who are trying to develop the aluminum for the industry, they have to gear up. And the volume has to be good enough for them to put up the capex to create that kind of extrusion which I said about 25 meters. So this debate continues on the aluminum and steel. Aluminum has an advantage, but are we ready to accept that challenge today in India? I personally feel no, because the speed level which is requirement. In India today, if you see, except for the train which is coming for Pune Metro, which Titagarh is making for Pune Metro, all other trains are stainless steel, whereas the Pune Metro is aluminum. Why it is there? Because he has got the technology from Ferema and he is exporting the complete shell from Italy. So manufacturing of car body for aluminum in India, I see it will take time. So from stainless steel perspective, there is a possibility of design optimization as I explained on train 18. There is a possibility of design optimization which you have shown on the wagon. In fact, the new wagon design concept which railways have come out has focused only on the weight reduction. So weight reduction on the car body under frame is possible. We have demonstrated in Bombardier, today Alstom, and all other foreign players have demonstrated in India that it can be done. And I feel that stainless steel future for India continues to remain as it is. There will be shift, but the shift will be only marginal 5 to 10%. So these are my thoughts on how the weight reduction which is possible.
One thing I want to just, what Mr. Dhingra said makes sense, but two things, India has a unique distinction of having a broad gauge. While most of the metro systems and the European systems are running on standard gauge or some other gauge, not the broad gauge. Even China has the standard gauge. So what happens, if anybody has to supply aluminum, he has to design a product for India, a specific. And I was personally in charge of upgrading the speed of a section of 160 kmph. Today, out of 70,000 kilometers of route kilometers in the country, hardly less than 1,000 kilometers is 130 kmph. So forget of 160 kmph, even 160 kmph in India is a dream today. And aluminum will not make a sense, as Mr. Dhingra said, unless the volumes are high. And volumes can be high only if your system has a high speed potential like China on a very large level. We are a country of maximum 130 kmph as on date because of the legacy issues of bridges and anybody who has to supply us, he has to design it specifically yours. I was personally involved in the 2 tenders in ICF for manufacture of aluminum coaches. We failed absolutely because of the cost involved. Mr. Reddy, you want to say?
Okay, this may be out of context, sir. I'm personally witness, sir. No, just 2 minutes, sir. I'm personally witness to the development of this train 18, which is revolutionary in our country because that is the one train which has come fastest and with the fastest speed, and it is making very good money, 2 trains running. And I had met Mr. Sharma ji, who became chairman also. And the backbone and the pillars of these are only 3 people I name. Maybe not of people are there. Trivedi Saab was the real chief mechanical engineer who was pioneering this along with his assistant, Mr. Srinivas, now presently CME, and Mr. Mani, of course, he was the general manager. These 3 people have revolutionized they've transformed the ICF from, I think, I used to say that I am a private man, but they are running better than private people. They were running company like as though they are owning that company, these 3 people, and they have really transformed that company. And as he said, from nowhere, this producing stainless steel was a big, great achievement, they thought, because RCF was producing nothing, because there are only unions, struggle, this, that. Output was very, very low, whereas ICF has shown there is nothing stainless steel or no stainless steel we can produce. Now they have produced from somewhere, I think, 1,200 tons, 1,400. Stainless steel itself, they are ready to produce 4,000 per year, maybe 5,000 per year. So all credit should go to him, and they have not got their due recognition. In fact, other than that, some CVC, all waste, negativity in the country. I used to feel bad because such a great thing they have done. The country should honor them with some.
One line I want to add here, since private industry also is here, the credit has to go to the railway engineers, but credit also has to go to industry engineers who have kept to the demand of the ICF to deliver that train within a time frame which is required. So it's a partnership of government as well as the private player who have delivered train 18. That's why I said that. So credit as a leader should be there, but let us not take the credit out of the industry. I just want to add.
So, Mr. Lahoti, now for the concluding remarks, because we have started manufacturing footover bridges and in various other areas, also railways. We have, other than the rolling stock, we are going for the stainless steel. So if you could throw some light on those.
So we have been talking mainly about the rolling stock. I'll share some thoughts about the civil engineering side. Already we are using stainless steel in infrastructure, particularly in stations. Our street furniture or the benches are predominantly steel benches when we provide on the platforms, also in our waiting halls. So recently Indian Railways procured almost 6,000-7,000 metric tons of steel benches for installation at various stations. So that is one thing which we have been using. The other thing is finishing items. Large number of finishing items in the stations and also in other service buildings are stainless steel, which are already in use, which includes the windows, the railings, the finishing materials, etc. Now coming to the bridges, recently Railway Board has advised all the zonal railways to try out with 2 footover bridges and 2 roadover bridges with the stainless steel on each of the zonal railways. So in this regard, Central and Western Railway, which are particularly in Mumbai, is corrosion prone. So have taken up three pilot projects of footover bridges on stainless steel. On Central Railway, it is being constructed at Thane and Kurla stations, and on Western Railway, it is being constructed at Bhayandar station. Similarly, the Maharashtra Rail Infrastructure Development Corporation is constructing some road over bridges, and those road over bridges will also be using stainless steel. So based on the experience of these bridges, we will be adopting more of stainless steel in the construction of bridges. But I think there is a substantial potential in the station redevelopment projects that Indian Railway is taking up, because stainless steel can be substantially used in the interiors of the stations and also in the structural elements of the stations. So these are some of the major infrastructure potentials which we can see in terms of the. We have tried little bit about the stainless steel reinforcement as well. Particularly, sir, you would be interested to know that there is something is being tried about the pit lines, where corrosion is a perennial problem, that we construct the catwalks, and within 10 years, because of the corrosion, the whole catwalk gets is in shambles. So stainless steel is being tried out in the maintenance lines also. So that is another field. There is also a potential for stainless steel in the track fittings, particularly in corrosion prone areas, where internationally some stainless steel track fittings have been developed and tried out. So those are few areas where stainless steel has the potential. Sir, and just to give some numbers on the rolling stock side, sir, as you mentioned, Indian Railway procure about 30,000 numbers of wagons in a year. So that would translate to almost 2 lakh tons of stainless steel, which is being procured by the industry for manufacture of wagons. And similarly, for the coaches, this figure would be of the order of 40 to 50,000 tons for the LHV coaches. Just to mention that the EMUs that we are procuring, the Bombardier rakes are completely stainless steel bodies, and also in the interiors, the seats are in the Mumbai Suburban are being provided with stainless steel. And then the grab rails, the grab poles, the grab handles, all these are stainless steel. Lot of fittings are of stainless steel. And in the brake systems in the rolling stock, so there is substantial use of stainless steel, like in the pipes for the brake system, the air reservoirs, in the air cylinders in the brake system, they are being used with the stainless steel. And in our coaches also, in the water tanks and in the bio tanks also, we are using stainless steel. So there is a lot of use of stainless steel taking place in Indian Railways. I think we can assign a figure of nearly 3 lakh tons in a year in Indian Railways. Thank you.
Thank you, Mr. Lahoti. And with this, we would like to bring this very insightful discussion to an end. And after this discussion is over, we are always here and ready for all the questions.
It's very, privileged to be here to talk to such a renowned people. I am not as old as Mr. Reddy, but I myself graduated in '69, so 5 years later than you. And you know, after having education from IITs, my first place was National Metallurgical Laboratories. And those days, National Metallurgical Laboratories was developing, grooved contact wire and catenary wire made of aluminum, because you use the standard wires. And because of the pentode touches that and there is a resonance, so fatigue is very important for that. So I was associated with our fatigue expert. So I tested on a vibrophore machine that what is the fatigue performance of this under resonance condition. So that was my association with that, I started with that. Later on, I find that railway is a place where there is a lot to learn. You see, and we have seen those who are older, 60, 70 years old, we have seen steam engines and electrification started. So a steam engine running on the same, this thing, corrosion was a problem. So you have enormous things. Second thing, that we saw was the great change in the speed of the trains. In our lifetime, we are now traveling at 120 kilometers per hour, maybe. And railway adopted the same technology probably as the aircraft industry. You have been in HAL. You use carbon-carbon composite, your brake system. Railway started because to braking distance would be 1,000 meter or so at that high speed. They use composites where the friction is very high and you are using a steel wheel. And probably, when you have a large friction, people have seen rail wheels, red hot. So there is a thermal fatigue that develops, and there has been many accidents. Even I remember I was just seated in Kurla, a very high-speed train, wheel has broken because of this. Then there is a failure of rails also, And there has been a lot of development, now we are not using ordinary steels, probably you are going for magnetic steels. And so far as coaches are concerned, you are not thinking only of strength. We are nowadays designing on the basis of a specific strength. That strength should be high and density should be low. And let me tell you, sir, that in aircraft industries, the people have replaced aluminum. Earlier, 15% aluminum was used. Now, Boeing 777 uses 50% aluminum. So there is a great transition from going from aluminum to composites. Even our fighter aircrafts, they are using carbon-carbon or graphite. I was wondering when all this talk was going on, is there no scope for composites? Because that is much lighter compared to your aluminum and things like that. Second thing I wanted to tell you is, you are using stainless steel. I have read in Australia, they have because high impact energy absorption in case of accidents. So they run the train probably at 250 kilometers and they made an impact like you do in your automobile sector testing. So they found that it has got great capacity to absorb energy. That is one thing. Second thing is, there is no concerted effort in our country. In Australia, they have got a railway engineering course, 4 years course, program associated with that. Here, you are a mechanical engineer, civil engineer, go to railways and you become expert of everything. We also become like that. So, we are learning from you, and only thing I think Mr. Lahoti is here. See, I have visited many of the workshops here, and you use about 300 varieties of different materials. So that is why it's a great learning place, for engineering colleges. And having spent about 40 years in IIT and retired from there, now I'm still active. You started becoming a unicorn at 67. I'm 73 and still working. So let us not talk about that. We can still work and you can contribute to whatever is there. But there is a lot of, I have visited your RDSO, I have given lectures there also. But there is no coherency between us. People talk of industry, academia, collaboration, but nobody thinks how this collaboration can take place. I have a lot of contact with this thing. I have done failure investigations of railway. Safety commissioners have given us some tasks. But there is no concerted cooperation between this academia and this thing. I think request you all to look into that.
Check. एक बार इनके लिए ज़ोरदार तालियां हो जाए प्लीज़ एवरीबॉडी. सर, इतना सारा एक्सपीरियंस, इतने सीनियर पर्सन हमारे साथ मौजूद हैं, आप प्रोफेसर भी हैं. वी आर डिलाइटेड टू हैव यू विद अस टुडे. एंड मंच पे हमारे साथ इतने दिग्गज अनुभवशाली जजमान बैठे हैं, इनके लिए एक बार ज़ोरदार तालियां हो जाएं. इन्होंने इतनी सारी इन डेप्थ इन्फॉर्मेशन आज हमसे शेयर की है. हमने बहुत सी चीज़ों के बारे में बात की, चेंजेस के बारे में बात की, दूसरे देशों के बारे में जैसे चाइना, जापान के बारे में बात की, एल्यूमिनियम, स्टील, स्टेनलेस स्टील, रेलवे कोचेस, बहुत सी चीज़ों के बारे में. पर लेडीज़ एंड जेंटलमैन, हमारे पास क्या है उसके बारे में हर कोई बात करता है, उसके बारे में हर कोई तारीफ़ करता है, बट क्या नहीं है उसके बारे में बात करने से हम कतराते हैं. विद दिस आई हैव अ थॉट, इफ विद योर परमिशन कैन आई जस्ट शेयर अ लिटिल थॉट. So nobody likes criticism, but constructive criticism is essential. It's better to know your blind spots than to be ruined by false promises. Isn't it, ladies and gentlemen? So with this, we conclude our session 2. Please give it up for our moderator and panelist once again.
Excuse me, can I ask you a question?
कहाँ से बोले आप सर? Yes. सर हमारे जो सर है ना, आप ही के लिए यही मौजूद है. हमने बिल्कुल ब्रेक नहीं दिया था पिछले सेशन के बाद, तो I'm so sorry, फिलहाल आपको थोड़ा रुकना पड़ेगा.
Started late.
सर 10 मिनट का लेट था जो मैंने 20 मिनट में पूरा कर लिया है.
Okay, no issues.
Sir, I will make sure I will get your question answered. So with this, I would request Mr. Anurag Doot, Head Projects, Virgo Communications and Exhibition, to please step up on stage and present memento to our moderator, Mr. Lalit Chandra Trivedi. Now I would request Mr. Anurag to present a memento to our panelist, Mr. Anantha Reddy. Followed by Mr. Harsh Dhingra. Up next, Mr. Anil Kumar Lahoti. So this was quite engaging session. I'm sure you all are looking forward for the next thing. So ladies and gentlemen, we're going to start with the next session in just like 15 minutes from now. So jaldi se वापस आइएगा. Please, we are waiting for you all. Because आज day 3 है और आखिरी के 2 ही sessions बचे हैं. So I want everybody, like all our attendees and guests, to make the most of it. And let me just inform you about the topic of our next session. So the topic of our next session is the role of digital in enabling business transformations for MSMEs. So see you sharp after 15 minutes. Thank you. Ladies and gentlemen, it's 1:30 and we're about to begin with our session 3 in like 30 seconds from now. So I request all our attendees and guests to be assembled in the conference area so that we can get started with our session 3 of day 3. Thank you. We'll begin the session in next 20 seconds. I request all our guests and attendees to be assembled in the conference area. Ladies and gentlemen, let's get started with session 3 of day 3. So the topic of this session is the role of digital in enabling business transformation for MSMEs. So ladies and gentlemen, I would like to call upon on stage the moderator of this session, Mr. Jitendra Agarwal, founder and CEO of Stainless Bazaar. Welcome, sir. Now I would like to invite the panelists for this session. To begin with, I would invite Mr. Akash Gupta, Head Business Development, Udaan Capital. Up next, I would like to invite Mr. Mohit Gulyani, Senior Director, Moglix. Lastly, I would like to invite Mr. Amrendra Tiwari, National Programs Head, Supply Chain Finance, Tata Capital. Now I hand over the mic to the moderator of the session, Mr. Jitendra Agarwal. Thank you.
Can you hear me? So this whole session is about how MSME is going to digitalize in the whole next 5 years. We firmly believe that, I think all of us believe that digital is the way to go. We have a small initiative called Stainless Bazaar, where stainless steel industry is going digital. We have 11,000 members and in 1 year, which is something that we never thought about. And we are looking at international members and domestic members put together 25,000 by end of next year. These are the people who want to cut out the middlemen. They want to go direct to the manufacturer and the supplier. And digital is a way. These are guys who have actually done it. Moglix, Udaan, Tata Capital, they have fantastic job they're doing in terms of digital. So I would love to ask Akash, I'll start with you. How is Udaan, what is Udaan? What are you guys trying to do? And how is Udaan going to take an MSME digital?
So, good afternoon, everyone. I am part of Udaan Capital, which is the fintech business of Udaan Group. So as you all understand, Udaan is a large B2B commerce platform. And to sort of successfully scale this platform, you need to have the ability to extend credit and also the ability to solve for the logistics of the transaction. So that has been the genesis of Udaan Capital, right? At Udan Capital, we work with manufacturers across different industries who are selling branded as well as non-branded products. And we tend to focus on the sales side of the manufacturing network, especially on the smaller distributors, the retailers, etc., right? Because we truly believe that that is the segment where we really need to sort of transform working capital, availability of credit, payment discipline, etc., right? That's a very brief introduction. Maybe we can continue this later. Yeah.
So I'll now pass it on to Mohit. He represents Moglix, which I don't know how many people know, but they are transforming the way the big businesses buy. Mohit, would you want to?
Yeah, am I audible? Yeah, thank you. So not just big businesses, but I think big businesses and MSMEs alike. And what we are trying to influence in Moglix essentially is, when we started out as a company, and I was explaining to Jitendra offline, you know, we understood the data of a lot of manufacturing organizations. And if you are MSME sitting in the audience, you'll relate with what I'll say, that whenever a manufacturing or an EPC organization buy their products, right, 70 to 80% spent went into raw material, goes into raw material, right? Then 10 to 15% is capex, machinery, manpower, electricity, etc. And then 5 to 10% is everything else under the sun. Now the problem is that although by spend it is just 5 to 10%, but in terms of number of SKUs, these are 70 to 80% line items contributing to just 5 to 10% of the spend. In terms of number of people engaged in buying these products across procurement, stores, shop floor, again, 50% people are just managing 5 to 10% of spend. And a long list of tail end vendors जो आपके सिस्टम में रहेंगे, आप देखेंगे कि इतना लंबा वेंडर्स का लिस्ट है, बट कंट्रीब्यूट कर रहे हैं हार्डली 10% स्पेंड में. तो Moglix went to all these manufacturing organizations and told them कि बॉस आपको इतना कम वैल्यू का सामान है, लेकिन इतना फ्रैगमेंटेड है, तो आपको इतने सारी जगह जाने का क्या ज़रूरत है. टुडे Moglix is one-stop solution. You can buy everything under this one roof, and you don't have to go from here and there. And आप vendors बनाइए, strategic vendors बनाइए, लेकिन talent spend के लिए why do you have to go everywhere? And that's where we came in, and luckily, fortunately for us, in our advent to do this, we got backed by some of the very good people from industry. Mr. Ratan Tata backed us from day one. So Mr. Tata was our backer from day one. He believed in our mission. He believed in our vision. We were just 5-10 people trying to do something in the industry. I came from manufacturing industry myself. हमने सोचा कुछ करके देखते हैं. And he believed in our vision and he backed us up. And today we are a team of 1,500 people across country, backed by best of the investors, and working across large manufacturing companies, small manufacturing companies, EPC companies, infrastructure companies, and consolidating their indirect spends, direct spends, packaging spends, custom spends today as one company. So that's a brief about us. Yeah.
Oh, it's lovely here. And Mr. Tata, I think, is a role model for everybody. Not only for you.
Definitely, definitely.
We also, my father is a big Taj loyalist. Wherever we go, he goes to Taj. So then, obviously, we come to Tata Capital, a company that not only is doing an amazing work, but because you guys have such an amazing brand. You know, Tata comes with, to my mind, the finest brand that India has. And you guys don't even need to spell what you do, just the brand itself is good. But at the same time, I've dealt with them for last 4 years, and we've had an amazing working chemistry. So, Amar, I do.
So, good afternoon, everybody, and thanks for your kind words, Mohit and Jeetu bhai. So, I will not get into Tata as brand or Tata as a group, but specifically to Tata Capital, I would want to, put out some points. We are a company working in finance industry for more than a decade now, almost 13-14 years. 2007 we started, and we have built this business brick by brick. We are a Tata Sons held NBFC. now supply chain finance, the portion that we, why we are here, enabling the trade basically in the domestic market is a core business that we have been doing since 2008 onwards. So, and that business over the years has, from being some industry specific, now at this moment we are, catering to all the industries. However, steel is a major portion, at least of whatever we, do as a business in supply chain finance. 20% of that book is coming from steel industry itself. And last 1.5 years, how steel industry has, been doing in terms of, price increases and requirement of limits and requirement of working capital to be able to, be at the ahead of the curve in terms of being able to serve your customers. And that's where we have been very effectively been, aiding, helping the trade of like the, dealers, distributors of steel industry by providing that capital. Now, just a last point on how we are, transforming ourselves also to align with the wave that is coming in form of digital. And as, Mohit and Akash mentioned, for last 2 years we have been building. So before 2 years we were, doing limits which were very large limits, like, crore and 2 crores onwards. Our average ticket size used to be 7-8 crores. But we saw, the change that is coming in the entire industry, and need to go down the, tail, as Mohit mentioned. So now we are capable, we have built that capability of being able to serve even the smallest of, requirement, funding requirements, and we are moving very fast in terms of adopting this digital landscape that is emerging in the market.
So my view is, can you hear me? The future is where we go to the MSME. And when we talk about MSME, it is micro and small, not medium and, we are talking about, let's say in stainless steel, companies which do 2 crores, 3 crores, 5 crores of turnover, per year. But they are the companies that we need to finance, that you guys don't even get to. Eventually, mere khayal se 80% of the companies are within that ambit. So that is where I think that you have to focus your, whether it's supply chain or your finance, directly to them.
Yeah, so, when it comes to the core grassroots level MSME segment, right, what Jitendra was talking about, if you actually go to the market, whether it is in ready-made complex in Indore, where you have got garment manufacturers, or you go to Jodhpur belt, where you've got Bartan manufacturers, if we talk about this manufacturing sort of setup, the problem statements are all uniform, right? What are the core problem statements that they want solutions for? One, they want to sell more, obviously. As a manufacturer, you are creating quality products, and now you want to sell that, right? And the moment you start selling it, you need to create a distribution channel, a retail channel, where you start extending trade credit, ranging from say 30 days to 90 days, depending on the industry, right? And the moment you start doing that, you are obviously taking that risk, whether my money will come back in time or not. And you're investing time and effort to, sort of follow up with the buyers. So the second core problem statement to solve for is, how do I ensure manufacturers are able to collect money back faster, right? And the third, more like, sort of a long-term problem statement which we see in the industry is, how do you drive payment discipline at the last mile leg, right? How do you ensure that smaller set of guys, in distributors, retailers, in tier 2, tier 3 cities, in rural areas, they find value to make timely payments. They understand the importance and, the power of organized trade credit, right? A formal credit. So on Udaan, we are working with close to about 3 million retailers on the B2B platform side. And out of that, on Udaan Capital, we have been financing close to maybe about 2.5 lakh retailers. And these are, the kind of profiles that you were talking about, like absolutely last mile segment, right? And I'm not talking about, profiles in say tier 1 cities or metro cities. So we offer them credit ranging from say rupees 50,000 to maybe 25 lakh, 30 lakh, right? So you can think of it as sachet credit as well, if you want to call it that way, right? So the kind of technology that we have created in terms of ability to underwrite these profiles, understand their profile, the credit requirements, that is something which we have been heavily investing on.
यही अपने को चाहिए इस इंडस्ट्री में, people like them who will back retailers and wholesalers, which is the last leg missing, and Mohit is doing the same with Moglix.
So not exactly same. So I mean, coming back, we are talking about digitization in this space, and digitization is the need of the hour. But when we talk of digitization, if we break down the functions, jab bhi ek MSME is actually in the business, the core functions he is actually engaging in is one is manufacturing of the products that he is manufacturing or selling, right? Second part is the procurement. For whatever he has to manufacture, he has to first of all procure something. And then finally marketing it, selling it to the external world. Could be retailers, could be its B2B clients, could be exporting also. And when you have to do that, you have to essentially enable it through finance, which a lot of good companies are now engaged in doing. So where we are trying to make a dent, apart from financing alone, what we are trying to do as a company in terms of digitization of MSME space is to enable these manufacturers or these SMEs to buy and sell in a digitized manner. Very simple question that we asked ourselves back when we started, कि आज अगर मैं we started in 2015, and very simple question that we asked was कि आज मैं Flipkart, Amazon से कुछ भी order करता हूँ, तो I can actually track when the product is going to come to me, when is it reaching my manufacturing site, right? But जब भी मैं industrial space में देखता हूँ, मतलब वहाँ पे तो मेरे को पता ही नहीं है मेरे shop floor पे कब सामान आएगा. When would I actually be able to receive it, then manufacture it, and then meet my commitments to my customers? So everything is dependent on the transparency piece, first of all. So by digitization, we first addressed this problem. We made a seamless supply chain for them so that they could buy and they could essentially see where is my product and when will it come to me. Then when they had made the product, now they had to go and market. So Moglix as a company, today we've got like 32 offices across India with our sales folks working across these offices. How can now a manufacturer sitting in, let's say, Mumbai can sell to someone sitting in east of India or northeast of India? So enabling that and making that market large enough for them was our goal. And then once we started doing that, we also identified that financing is one gap they need to plug, and we kind of tried to fix that by extending support to them in terms of either raw material financing or then final leg of selling. So taking the piece as a whole and trying to serve each part of the problem is what we tried to do. Today, by the way, we are engaging with a lot of manufacturers in implementation of Industry 4.2, in implementation of predictive maintenance. So getting to that level of technology as a problem and solving it using digital is what we are trying to enable. Yeah.
No, it's amazing what you guys are doing, and in such a short span of time. And obviously, going back to Tata Capital, which is you are the pioneers in financing, and especially now getting into MSMEs. So where I would want your input is कि हमारे यहाँ जो है वो ज़्यादा करके micro and small, even MSME, you have micro and small as the biggest contributor to our industry. Yeah. How can Tata Capital help with it?
So to make this point, I'll just take an example. I think 2016-17 onwards, we heard the word UPI payment. Okay, and just by instead of a credit card or any other payment method that we used to use earlier, we implemented UPI in India, which is more like Aadhaar based or mobile number based transaction enablement for payments basically. Nobody had thought that UPI payment platform will become such big. We are, I think, as of now, we are largest, largest in the world, India itself, doing the transaction of payments through the mobile phone. And so our vision, along with many industry players, is that can the credit to this segment, MSME segment, be extended in the same seamless manner. जैसे आप खड़े होके कहीं पे भी 20 रुपए का भी पेमेंट करना है तो you can do it through the phone. Can we look at a scenario, maybe if not immediately 1 year, 2 years down the line, where just through the phone, you as a borrower want to avail a credit of say 50,000 as Akash was mentioning, or it could be even larger amounts. It can be done instantly and also without need to go to the bank or an NBFC for filing applications, this that. You just, because there are three things that have changed since then. One is everybody is Aadhaar, everybody has Aadhaar, which is an identity. What do NBFC need? They need to fix the KYC problem, which is more or less taken care by Aadhaar. The other is contactability in terms of mobile number, which is there, and then a bank account statement or whatever. So those assessments can be done now digitally. And I'm very happy to share. We are already doing this product. At a small scale, it has started since last year, where irrespective of the time, like even at 12 o'clock in the night, if there is, so it is very specific to one use case. Most of आप लोग को शायद पता होगा GEM portal है, government e-marketplace, where government departments are procuring their stuff through that portal, and those purchase orders can be financed seamlessly, instantly through a mobile app which is called Gse. And there Tata Capital is financing those purchase orders issued by the government departments. Instantly, like within 2 minutes, the fund is transferred to the customer. So it is just a use case which is building. And we are hopeful that in 6-7 months or maybe 1 year down the line, we will have more such products which will target customers, as you mentioned, the individual proprietorship firms and those kind of MSME segment where.
So Amar, that is what we want to target. So let me give you an example. This gentleman who is just sitting right across you is one of the finest re-rollers of stainless steel. But then if we have to sell his product, we need customers who we can finance, because they will need credit and they will not obviously pay against material. Yeah. MSMEs are like that. Tata Capital and Udan and everybody has to come together to build a case where these guys have the comfort to,
so just building on that point, as I mentioned before 2 years, we were only looking at larger limits where, assessing the customer or the borrower was more or less easy because there was a lot of, compliance, like ITR is filed and income papers are available. Now we are in a regime where GST is a, uniform thing which is available the moment you are dealing in goods like steel. I think most of the people are more or less compliant. So that data, how do we, access and leverage that data to be able to arrive at a limit for anybody who wants to avail finance? So that is the work in process. I think just to make a point that now we are capable to extend credit starting from 10-15,000 up to crores of rupees that we have to do. And process is, as you grow in terms of exposure requirement, the processes become little more detailed and more I would say.
Yeah, so I think the way we look at this market is, we have been talking about digitization, technology, and different products have been coming in the industry for the last 5 years, 10 years or so, right? It is fairly easy to talk about digitization, talk about fantastic product, but actually driving adoption of those products is something which is very critical, right? You can always give somebody, you know, a particular product and say, feel good about it, right? But if that person ultimately is not using it, then there is no value that you are adding into that particular person's business, right? So one of the core things that we have been focusing on is how do we sort of, you know, streamline the user journey, streamline the user flows, right? So if somebody is coming to, say, a Tata Capital or an Udaan Capital, they should, you know, find it so intuitive that they don't have to, you know, ask anyone what is the next step, right? It has to be a seamless onboarding journey. That is where, you know, GST, Aadhaar, etc. have been helping us. I'm sure, you know, Tata Capital, Udaan Capital, bunch of other fintechs, lenders, we have all created a digital acquisition journey, right? Wherein you don't even have to, for example, today if you have to apply for a credit on Udaan Capital, it is completely paperless, right? You don't really have to upload a single document. It's all plug and play kind of a model, right? So we have been focusing a lot in terms of seamlessly giving a good user experience to these buyers, which are essentially small retailers, distributors. The second thing, which is core and I would say proprietary to Udaan and Udaan Capital as well, is how do you look at alternate data points to underwrite credit, right? What exactly are you trying to evaluate? You are trying to evaluate two fundamental things. Is there an intention to repay? Is there an ability to repay, right? Is there alternate data points which are already available in the trading ecosystem which can be used and masked to sort of build a credit profile? So a lot of companies have been working on these kind of models, and if you look at the US markets, those are tremendously advanced, yes. Correct. So, you know, on the Udaan platform, we are currently doing a gross merchandise value per month of around 1,100 crores. And that's the kind of, you know, scale at which we are operating, and that helps us to understand the trade better. We are not there in the stainless business as of now. So Udaan Capital is there into, you know, providing working capital support to the manufacturers, but as a category on the B2B platform, we are not yet there. Yeah.
So what I'd like to just pitch in was just build on from what Akash said. Essentially, platform banana easy hai. Uska adoption drive karana is going to be extremely difficult. And a lot of times products have actually failed when they were ahead of their time, right? A lot of apps would not have run agar internet revolution nahi aata. हम जियो वर्ल्ड सेंटर में बैठे हैं, अगर जियो नहीं आता तो ट्रस्ट मी इंटरनेट गांव-गांव नहीं जाता, राइट? सो इट हैज़ टू बी एट द राइट टाइम एट द राइट प्लेस एंड द प्लेटफॉर्म हैज़ टू बी सीमलेस. मतलब आज अगर हमें गूगल सर्च करना है, नो मैटर कितना कॉम्प्लेक्स इंजन बैकएंड में चल रहा है, वी जस्ट हैव टू स्टिल सी अ वेरी वाइड स्क्रीन एंड जस्ट एंटर एंड गेट द सर्च रिजल्ट्स. And that's probably the reason companies like which were too cluttered, like MSN and Yahoo, they eventually died, almost died, right? Lekin no matter what systems you make, okay, all of them are dummy systems. Let me call it out. जो भी AI, intelligence, जो भी बोलते हैं, all of them are actually dummy systems. All of them work on a simple principle: garbage in, garbage out, right? अगर आप सही चीज़ डालोगे तो सही आउटपुट देगा, अगर आप गलत चीज़ डालोगे तो आपको अपना desirable output नहीं मिल सकता. And when we started our journey at Moglex and started working with a lot of MSMEs and manufacturing organizations, what we saw was कि उसको चाहिए एक प्रोडक्ट बट सिस्टम में लिखा कुछ और ही हुआ है, राइट? दे वांट लेट्स से दे आर बाइंग अ पेन, अ सिंपल प्रोडक्ट लाइक पेन, एंड दे आर बाइंग अ पेन फॉर 5 रुपीज़ ऑल्सो एंड दे आर बाइंग अ पेन फॉर 5,000 रुपीज़ ऑल्सो. अभी वो पेन 5 रुपये का रेनॉल्ड्स का पेन है या वो 5,000 रुपये का कोई लग्जरी पेन है, दैट वाज नेवर मेंशन्ड, राइट? अभी इट वाज रिटन स्टेनलेस स्टील प्लेट चाहिए. What grade, what thickness, what size, what dimension, what quantity, because MOQ नहीं होगा, price will change, right? Nothing was mentioned. So we identified that as a problem and tried to fix at the right point. There was no catalog per se, a digital catalog that ever existed in India, and हर manufacturing company में जिसको जो समझ आता था वो part code और descriptions create कर देता था. And then suppliers like me, suppliers like Stainless Bazaar used to feel difficulty in कि बस आपने लिखा ये आपको चाहिए क्या, right? And your system, no matter how digitized it is not helping me. कंपनी में SAP लगाने से प्रॉब्लम सॉल्व नहीं होगा, एक्चुअली उसमें राइट डेटा फीड करने से होगा. सो व्हाट वी एसेंशियली ट्राइड टू डू वाज बिल्ट टुडे वी कॉल इट कैटलॉग फॉर इंडिया. टुडे नेम एन इंडस्ट्रियल प्रोडक्ट, Moglix will have an absolutely right definition of that product with images, with specifications, with part codes, with descriptions, with grade, with thicknesses, everything mentioned in a very, very clear and concise manner. And that's what we enabled. And today, all the MSMEs and all the manufacturing organizations which work with us, a lot of large ones already do, they are essentially, for them this problem is fixed once and for all. And now, they can buy at a right price from the right supplier and then get financed by the right partners. Yes.
So Amar, how does Tata Capital, you already mentioned that you are going to the last mile now. You know, Tata as a brand and Tata Capital, we would love for you to partner with all of us to actually finance the right guys, absolutely the MSME guys. This is where Tata Capital should, to my mind, come in.
No, so that realization is already there, as I mentioned, and we are already on that journey to be able to not only, be able to fund the tier 1 where, the sales is happening from the corporate to the distributors, but also to reach out, because what we realized in the journey over last 4-5 years, while we are funding the distributors, there's a lot of, and in many other words, Mohit and Akash, you also mentioned, the problem the distributors or the dealers are facing also is of the receivable realizing. How do they, get their money faster, and they are able to rotate. So it's more of a rotation business. The more you churn, more you make money. So after understanding this problem, we started this journey of, going to the tier 2 is what we call. We have launched basically a journey which is called Sugam Loans. It's Sugam in the sense we are aiming to move away from paper. So the two keywords for our, offering to this segment, the last mile segment, is paperless and faceless. Like I should not be coming, or you should not be required to come and, apply and then seek whether my loan application is approved, my limit is approved or not. It should be faceless, means your mobile phone, or if you are using a computer, it should be good enough, basically instrument which is able to, make you this facility available. One is that, and then comes the last leg of transactions. So for transactions also, you should be able to, do the transaction simply the way you transact for making that payment through UPI. That is the whole idea, and that last leg is already there with us. It's only the second and first leg where we are looking at, developing, and it is already under development, under implementation at some legs in terms of paperless and faceless. The more adoption of, GST, Aadhaar, bank statement through digital means, among, the target segment, I think we will be able to quickly adopt those, facilities to offer the credit to the last mile very, very easily. And that's the hope, and I think adoption, as Akash you mentioned, and Mohit also, that is going to be the key.
No, that is going to be the key. So any questions we have?
Credit at what cost, Udaan and Tata Capital? Cost क्या रहेगा? The rate of interest.
So cost of credit is it's a risk pricing. So it depends on the risk profile of the borrower. If the risk is, absolutely towards, so, I mean, we can't compete with the pricing that is offered to the larger corporates because, yeah. So it is, no, so that is one part of it. Extending credit to a segment where, as of now also, if it is an informal credit, we know what kind of pricing they have to sustain. It's almost like, I think I hear it goes up to 30–40% annualized return. So not to your industry, I'm saying other industries where it is informal credit, 2–3%. So I think we are in that range. Yeah.
So minimum is what and maximum is what? If Ratan Tata comes, will you be giving at 1%, 2%? Or if I come?
1% what? 1% annual?
Yeah.
That's
Yeah, it's a 6–7% annual is available now. Yeah. So if he says the risk, so if Ratan Tata comes, it's 1% annual, or Arshad Mehta comes, it's 7% annual. What's the average?
Okay. We are in business of financing and making money also. So our source of capital is mostly borrowed. There is some amount which has come from Tata Sons. Rest of the money is borrowed from banks and whatever institutions who are in lending money to us. Now, and most of it is public money. So we have to balance two things. One is that I have to ensure that whatever credit I am extending to the market, I am ensuring that it is safe and it returns to me, so that I can repay the public money to the banks and all. And second is that I should be able to make some margin also on that, so that our organization runs, I am able to pay back to the shareholders, and also I am able to repay to my lenders. So giving that calculation, currently we start from around 9.5–10% to the best of the profiles, and then we go up to whatever, depending on the credit profile of the customers.
Okay.
So there are two questions. Do you have the rating for the companies? How do you do that? And secondly, there are more laymen into Indian businesses. So how do you compatible them? See, there are some facilitator centers. What is the facilitation for them to be in your platform?
Could you repeat the second question?
Yeah, first is how do you rate the companies? Second is what is the facilitation provision? Suppose if I have my area of order, there are a lot of consumers. They are hardworking, but they don't know how to apply for this. There are no help desk. So how do you do that? How do you connect the missing link between you and the customer?
So Kushalji, we are running a program in Home Zone in my company, where we are now like an anchor finance with these guys, and we finance smaller companies from 25 lakhs, 5 lakhs to 25 lakhs. And this is how we are building it up. We are starting the same with Tata now. To my mind, we're the first company who's going downstream in terms of financing the smallest of the guys. You could have a 5 lakh ka limit, 10 lakh ka limit per month, and that's how we are doing it.
Yeah. So great question, first of all. So if you're a manufacturer, right, what is my goal here? My goal here would be to be able to de-risk your business, right? Let's say you are doing a monthly turnover of say 20 crores, and that amount is being sold to a buyer network of say 500 who are spread across the length and breadth of the country. Instead of you extending them trade credit and following up for payments, waiting, etc., which chokes your working capital, it increases your business risk. Can you partner with a fintech or a lender who are able to offer a credit line to your smaller set of buyers, right? To answer your first question, how do we sort of go ahead and evaluate? So fundamentally what we do is we look at your GST data. Basis that we have some sense of, the how many parties are you dealing with, what is the month-on-month transaction that you have with each of these guys, right? So basis that information itself, I can quickly decide that will this be a 20 crore kind of a program or will this be a 5 crore kind of a program? And if you are working with say 500 of your distributors, I'm sure you will have their GST numbers wherever they have GST, right? Simply basis their GST information, most of the fintechs or lenders today have reached a stage where they'll be able to sort of do an initial filtering that look, out of these 500, 400 are on GST, and out of these 400, we are prima facie okay to give a credit limit to maybe about 300 of these guys, right? Then it's a question of distribution. So, you know, what we like to call is, this is hardcore SME lending, right? Where we are talking about micro MSMEs, right? So it is more about distribution of credit rather than me taking a pen and paper and getting their bank statement, etc., right? So how do you leverage technology to, you know, inform each of these buyers that you are extending a facility where the buyers can enjoy a credit card kind of a product, right? Where they have say 45 days or 60 days of interest-free period. And beyond that is when they are getting charged for the facility, right? So we are leveraging technology there as well. And then, you know, Amar was talking about the onboarding flows where, you know, essentially you create a digital journey where without taking any piece of paper, simply by GST data, bank statement data, we are able to arrive at the credit limit. So I think broadly it works like that. And I'll let Amar also add to this.
So credit rating, as you said, basically what I am understanding, credit assessment कैसे करते हैं हम लोग? How do I identify that, okay, for this customer कितनी limit बननी चाहिए? So Akash had earlier mentioned, you know, we look at two things. One is intent, and that we check from the credit bureau. Basically, when you submit a PAN number and your, you know, your credential as an identity, we go back and check the credit records. आपका past record in terms of servicing loans and whatever facility you have taken, उसमें कैसा रहा है? So that to a level, certain level, you know, it indicates that you continue to be the way you are and you have been repaying the loans that you have been repaying and you will continue to do so. So that is one part. Second is capability. Now capability so far in the earlier world has been identified by the, you know, kind of returns that you have been filing, income tax and, you know, those kind of your audit reports and all. But in the world that we are now and we are moving in, GST is a major source and your bank statement. So these 2-3 documents will, you know, define your capability. More than capability, it will also define the, you know, your consistency of business with, you know, those many people. So अगर आप consistently किसी के साथ 10 लाख रुपए का महीने का बिजनेस कर रहे हैं, so that, you know, from algorithm that we could, you know, from past data and all, ledger वगैरह analysis करके, we can identify that this 10 lakh can only become 12 lakhs in 1 year time or whatever, and for that, what is the limit required? So that is how we assess the credibility and credit limit. So that's one part. Second part is very, very pertinent, you know, question you raised. In terms of, we may have, you know, all the best of the technologies and best of the services available, but if the customer who has to use is not aware, then what do we do? So there are, I think, to my mind, we have two solutions, and it will be a collaborative effort from all the participants in the industry. Everybody has to come together and, you know, promulgate this thought. One is digital means, that we, you know, keep on reaching out to the masses, to the target segments, and digital in that sense is quite effective because we can target the, you know, precise segment that needs that credit facility to basically popularize that there is a facility available like this. And second is, as you said, association, ODA का आपने नाम लिया, वहाँ पे we can, you know, so but there are so many industry associations. How do we, that's little difficult problem to solve, but I think as a, you know, community of financiers, we should try to do something over there that, you know, okay. So all the associations we can create one, because the market is humongous. It's not a competitive, you know, the lens doesn't have to be competitive in terms of मेरा हो दूसरे का ना हो. It has to be a collective effort, and I think everybody will have enough to, you know, chew.
Hello.
So yeah, I'll be able to answer more on the procurement piece, selling piece. Credit is one piece, which these two guys are definitely expert. Yeah. So yeah, please get in touch with us. We are at moglex.com, and there are numbers provided. My cards, and I am here, and I have few members from the team also here. You can get in touch with us to digitize your procurement, to digitize your manufacturing supply chain. We can come in and have a role there. Yeah.
No, I think broadly, sort of closing remarks, I wanted to talk about how, as an industry, we can move forward with digitization, right? Like Amar rightly mentioned, one of the things that is need of the hour is to actually collaborate more with, you know, trade associations, industry bodies, and in fact, larger corporates also, who, if they want to drive this digitization agenda till the last mile, it creates a lot of, you know, trust and belief that this is the future of things, this is the future of working, right? The second thing that we genuinely believe is, you know, trying to make things simple and intuitive, right? Today we have reached a stage where, you know, WhatsApp has sort of transformed digitization, right? We are on the consumer side, digitization is there pretty much everywhere, and technologies like WhatsApp, Paytm, etc. are being used by businesses as well, right? Now, how can you create something seamless, something as intuitive as WhatsApp on business processes related to procurement, related to financing, related to collections, right? So those are areas that we need to work on. And lastly, my honest belief is, as and when, you know, India starts growing leaps and bounds on the entrepreneurship side, automatically digitization is also going to grow, and that is where a lot of policy intervention is happening. And I feel that strongly Government of India and a lot of the associations are making a good progress, right? So that's what I strongly believe in terms of the way forward for digitization for MSMEs at least.
Check. So I would like Arun to talk about Stainless Bazaar, what we are doing in the same sector.
So, check.
Check, check.
Hi, very interesting discussion, guys, and thank you so much for, you know, very interesting thoughts on the topic of digital transformation. See, what I feel is Stainless Bazaar, because, you know, the opportunity in this industry is that there is a lot of digitization still left to be done in this industry, which means that, you know, there's a complete digital ecosystem that can be created, and which is what Stainless Bazaar is trying to create. We started by, you know, getting all the ecosystem players on a single platform. So in terms of whether it is raw material players, it is super stockists, wholesalers, dealers, even retailers, manufacturing companies, they are on a single platform called a Stainless Bazaar, where they join to build a community. They can participate, they can interact with each other, they can get to know each other, they can get industry news. Then followed by they can, you know, do buy and post leads. You know, they can trade between themselves. And this is just the beginning. We are right now free. We are about to launch our memberships. But as we go forward, you know, we are pretty much trying to build not just discovery platform and a community. We are trying to create a complete transaction platform with financing options available. So by transaction, I mean, you know, two people want to do a trade, but there is someone required in between to put the trust, someone required in between to put the fulfillment, someone required in between to do the trade financing. And that is where we are going to do what Stainless Bazaar is going to do. So right now we have started in India, but hopefully this might be very soon a global enterprise.
Yeah, hopefully, very soon. So yeah, I think any last comments? I think at the end of the day, MSME is what is going to benefit from this. The real beneficiary is going to be the smaller players, and whether it's Moglix, these guys are now valued in billions and billions of dollars. But the real crux of their company is MSME, if I'm not wrong. So whether it's Udan, Tata Capital, Moglix, whatever, I think at the end of the day, unless you have the real small guys who are attached to you, there's no point of, so this is the country that we are now going to build. And let's focus on the smallest of the players. This is where the real value is. Those are the guys who need you, not the big guys. So to my mind, yeah, that's where we are. Any closing comments?
No, I think, like I said, we are looking forward to working very closely with everyone, learning from your, individual experiences and co-creating solutions, right? That's the way forward.
No, and thank you, Jitendra, for this wonderfully organized platform. Only thing I strongly, very, very, very strongly believe is that today, if India has to grow, the 40% of the MSMEs which contribute to that percentage of GDP have to really grow and contribute. India aspires to become a 5 trillion economy from a $2.5 trillion economy that it is today within 5 years. And if that sort of pace has to come, I mean, doubling our economy within 5 years, who is going to propel it? It is going to be companies like us and yours, which is going to definitely do it. So, I mean, before I close, a huge round of applause to all you guys.
So, from Tata Capital completely believes that digital is not a journey that is getting reversed. It is a way forward only. Everybody has to adopt. If a guy standing, an uneducated guy, and Akash, you mentioned about WhatsApp. Everybody is using WhatsApp. Everybody is using UPI. So I don't think it is very difficult for the MSMEs to also adopt the digital way of doing business. It is going to happen. It's only about when and how it will happen, and who will be the who will be the people at forefront of these changes. I think Tata Capital is committed and trying to be at the forefront of these changes, and we will be there for you whenever there is a requirement of credit facilities and all. We are quite committed to this cause.
Ladies and gentlemen, can you please hear it for these wonderful people, those who were here for the session. Jaiye mat, sir. Sir, please be on the stage. All four of you, please be on the stage. So this session was quite engaging. Of course, digital is the present and future. We spoke about need of the hour. We spoke about de-risking the business. Well, Mr. Akash and Mr. Amrendra, you answered questions very, very well. समझ में आना चाहिए जो हम पूछ रहे हैं उसके आंसर्स दिल तक आए और दिल से दिमाग में आइडिया आए, ये बहुत ज़रूरी हो जाता है. We also spoke about UPI payments, credit assessments, important role of spreading awareness about your facilities. Digital है, भाई आगे भी वही रहेगा. With this, I have a thought. So जैसे कि आप देख रहे हैं, digital is of course a very good opportunity. So if you guys permit, can I just add a small quote? So it's not about having the right opportunities, okay? It's about handling the opportunities right. Use it or leave it. It depends on you. You all are creating a better India. Congratulations to all of you. And with this, I would request the moderator of our session, Mr. Jitendra Agarwal, to please present memento to our panelists, starting from Mr. Akash Gupta. Followed by Mr. Mohit Gulyani. Congratulations, Mr. Mohit, like started in 2015 and now 32 offices all over India. Great, going great. And followed by Mr. Amrendra Tiwari. And to present memento to our moderator, I would like to invite on stage Mr. Raghunath, MD, Virgo Communications and Exhibition Private Limited. It was wonderful to have you gentlemen up on stage to have such engaging discussion. With this, ladies and gentlemen, we come to an end of our session 3 of day 3. We will begin again within a break of 30 minutes. So please stuff yourselves, enjoy. This is the last day and be back within 30 minutes because the last session, it's going to be again informative. Thank you.
Check, check, check. check, check.
Mic test. Check.
you, sir, on stage. Ladies and gentlemen, we are about to start the very last session of day 3 of Gse GSSE 2022. So I would request all our attendees, all our guests to be assembled in the conference area. Sir, आप बाहर से ज्ञान मत लीजिए, अंदर आ जाइए. We have chairs waiting for you. You all can come inside and make your day a very productive one. So this session is going to be quite different, like the way how we conducted 10 other sessions. तो इसका format थोड़ा अलग होने वाला है. So I'll let you know how it's going to be. Shortly, we're going to start with the session. So ladies and gentlemen, here we begin with the last session of GSSE 2022. शुरुआत तो हमने शानदार की थी, लेकिन अंत कुछ धमाकेदार होगा यहाँ पे. As you can see that we have a different format of this session. So we will of course have a panel discussion, but along with that, firstly we're going to start with the presentations. So firstly, let me introduce you all to the topic and to the moderator and the panelists. So the topic for our session 4, technically session 11, is fueling new applications for end user, industries and emerging markets, hydrogen and ethanol. So moderator for this session would be Mr. Rajiv Sherry, MD, Autocompo, India. So can we please hear it for Mr. Rajiv Sherry, everybody? And the panelist for the discussion would be Mr. Rajesh Alreja, VP Engineer and Procurement, Godrej Process and Equipments. Mr. Mrinal Das, Senior VP Projects and NGG Purchase Engineer, Dorf Kettle Chemicals. Mr. Ravi Verma, Founder and MD, Hypro. Mr. Abhijit Dani, VP, Critical Process Equipments and Modularization, Praj Industries. So we're going to start with a presentation, and we're going to start with Mr. Ravi Verma. So over to you.
Good afternoon, everybody. I'm Ravi Verma. I'm the founder and managing director of Hypro. Hypro is a company established in '99, and we are a turnkey solution provider for brewing industry, carbon dioxide gas recovery industry, alternate fuels. We are working now on alternate fuels and the hygienic process solutions. When we talk about hydrogen, we need to understand what are the challenges for making the vessels, the piping, and the valves, and all the handling system which is part of hydrogen. So let's start at possibilities of material that can be used for hydrogen transport and handling. Hydrogen is stored and handled at temperatures between minus 255 degrees centigrade and up to maybe 30 degrees centigrade. The pressure could be from 12 bar to up to 700 bar. It is stored as a liquid or gas or in supercritical state. It's one of the most challenging chemical to handle and store. It's highly reactive. If you see at a pressure of 350 bar and at ambient temperatures, the density of hydrogen is about 21 kilograms per cubic meters, which means to store 1 kg of hydrogen, you need about 47.6 liters volume. If you want to reduce the volume, we increase the pressure to about 700 bar. Again at ambient, the density changes to 42 kg per cubic meters, and you need a volume of about 23.8 liters to store hydrogen. So when we talk of hydrogen as a fuel, what we need to do is to minimize the volume for transport vehicles or trucks or anything. And the minimum volume people talk is about 5 kilograms, which means you have a tank of about 125 liters or maybe 200 liters depending on the pressure. If we go to liquid hydrogen, the temperature is minus 252.9 degrees centigrade. The density is higher, it's 71 kilograms per meter cube, and the volume required is only 14 liters. But the challenge here is the temperature of minus 252, which means it's in the cryogenic range. And then you need to have special vessels which are double walled, which are vacuum insulated, and there are a lot of challenges handling this kind of liquid hydrogen. This would be only used for space and other technologies, but for commercial vehicles and transport, it will be mostly either 350 bar or 700 bar on the fuel stations. Next. Now let's understand the risks that are associated with handling hydrogen. It is extremely flammable, and it forms an invisible flame, and yet hence it's a great risk of thermal injury. I mean, you can't see the flame. It's flaming, but you can't see it, and somebody touches it and he gets thermal injuries. So that's a huge challenge with handling hydrogen. It's colorless, it's non-toxic, but it can displace oxygen from the surrounding air, and there's a huge risk to humans. If suppose hydrogen is stored in a closed environment, and if it leaks, it is going to displace oxygen, because it will react with it. And the moment the oxygen percentage falls, it can fall to below 18%, and then it's a huge human risk. So we need to understand the risks associated with hydrogen when we talk it as a... So if we look at the material selection challenges, the first challenge is high pressure, up to 800 bar. Low temperature, minus 252, only stainless steel can stand these temperatures. Chemical properties, it has an ability to permeate metals. It reacts with metals, it permeates metals. And the biggest challenge with hydrogen is embrittlement and stress corrosion cracking. So it can embrittle the material, the ductility falls, and then the strength of the material falls, and then it can crack, and you have huge challenges handling hydrogen. So these are extremely crucial parameters while we look at the materials for hydrogen. Next slide, please. So what are the possible choices of material? There are carbon steels which are used for cylinders and other applications. But we have to design the vessels with lowest tensile strength. Suppose you are using a normal safety factor of 1.5. Here you should be using a safety factor of 2, because you need to design hydrogen vessels and piping at a lower stress value. And at also lower head rates less than 250 HB, and only for temperatures higher than 10 degrees centigrade. Then there is austenitic stainless steels, SS300 series in annealed condition. Other stainless steels such as ferritic, martinistic, duplex or precipitation hardened, fully annealed, heat treated as per the grade. Selection always with lower stress values. Next cell. So these are typical photographs of cylinders of hydrogen, tanks of hydrogen, tankers and road transports. So the material which we need should be higher strength, it should be immune to hydrogen embrittlement, there should be ease of welding, cutting and forming. So the recommended material here is alloy or special grade of SS316L. Normal SS316 cannot be used for hydrogen unless it has got some special additives. So we are talking here of higher nickel content in excess of 10% and maybe up to 14%. There should be presence of manganese, there should be presence of molybdenum, the sulfur content should be less than 0.01%, phosphorus content should be less than 0.015%, the nickel equivalent should be 32% or more, and what we talk about nickel equivalent here is by mass percentage. This is a formula, so this is more technical. We can, it can help you. It's about 12.6% carbon plus silicon and manganese plus nickel and chromium and molybdenum. So all these components play a certain role in hydrogen. If you see, there's a graph which shows that what is the related retained tensile ductility when there's a nickel percentage. So if you see if the nickel is less than 10%, it's not suitable. The minimum nickel should be about 10 to 11%, and as we go at about 14%, the graph plateaus down, and then you have better suitability of hydrogen to handle hydrogen. So stainless steel has to be special grade. When it comes to surface finish of the vessels, valves and piping, there are surface finish specifications for the vessels and piping to avoid sites encouraging for hydrogen attack. So if the vessel is, the material is not good, I mean it has got some scratches or cracks, the hydrogen is going to immediately attack those cracks and you will have stress corrosion, cracking and corrosion of the material. The valves that we use have to be high pressure and with double sealing of the stem. Go back to the previous slide. Go back. Welding of pipes with controlled inert environment, smooth penetration and surface post welding, and the inspection has to be with the boroscope. Next. And when we talk about hydrogen, there is a possibility of a future alternate fuel, which is methanol. And CO2 today is a waste product, and it's a chemical which people are not wanting to be let off to the atmosphere. So if we are able to react hydrogen and carbon dioxide, it will form methanol. And methanol can be a good alternate fuel in the future, easy to handle, and it's a good solution. At the moment, the cost of hydrogen is going to prohibit this process, but technologies are getting advanced and people are working on it to make alternate fuel in methanol. When it comes to CO2, we have built a lot of CO2 plants, and there also we are kind of replacing all the carbon steel with stainless steel, because stainless steel has got its own inherent advantages in using for CO2 application. There is no corrosion. Although we are talking about double the price than low temperature carbon steel, but there is a possibility of half the thickness using stainless steel with certain special criteria. So we are promoting stainless steel also for CO2. Thank you.
All right, so this was our first presentation, and for the next presentation, I invite Mr. Abhijit Dani, VP, Critical Process Equipments and Modularization, Praj Industries.
Excuse me, can we have some questions on this so that if audience is having any questions? So first of all, I would like to introduce Mr. Ravi Verma, and I am just reading a note that I have received. Mr. Ravi Verma got a graduate degree in chemical engineering in 1992, and he started his early career as an employee only for 6 years. And at the age of 27, he started to his own business. So at the age of 27, he became very young entrepreneur. And that is the way he started his company from one room and with a capital of less than 20,000 rupees, $300, he started this company. And today, because of his dedication and efforts, he has taken this company to such a high level. And if we see today, Hypro is an established name in the industry, and they are not recognized for reliability and quality, but they are also a trustworthy partner for many across the globe. And having its worked and delivered to India, Asia, Europe, and USA. And Hypro supplies systems and plants for microbreweries, craft breweries, industrial breweries, carbon dioxide recovery plants, liquid processing plants, and pharmaceutical, beverage storage, and list is very long. And he also has 2 patents in his name. So a big round of applause for Mr. Ravi Verma, who could find time and be here. And after hearing from him, very nice presentation, very lot of new information that we have received today. If anybody of you would like to ask any question, you are most welcome.
Thank you, Mr. Verma, for a nice presentation. Although I missed the previous, I came late, but I was listening to about the stories. My question is very straightforward. You are thinking of stainless steel for hydrogen storage. Why don't you think composites for hydrogen storage? Because in open literature, if you see United States, I mean, there are a lot of research being done, for hydrogen storage composite materials. Even for CNG, people are thinking of composites and composite things like that. So what is the problem with using composites?
Yeah, the composites can be used, of course, but they should be based on stainless steel because of the advantages of stainless steel with higher nickel. It stops the hydrogen embrittlement and the stress corrosion cracking. If you use composite materials based on carbon steel, one day they are going to be severely corroded. And if you are looking at longer life, then we would prefer stainless steel. There is no metal which is totally immune to hydrogen. It's all a relative term, and that is why we are always saying that hydrogen is a very difficult material to handle. Yeah, so that's why we have said normal stainless steel 316 we cannot use. We need to make an alloy with certain grade of nickel, molybdenum, manganese, and certain chemicals in it. So it is not a normal stainless steel.
Yeah, so any other question from the audience? And if you permit, I can ask one question if it is okay with you.
Please.
Yeah, so I wanted to check that hearing your presentation, so how do you see the growth of stainless steel industry? Because I think you covered in your presentation a lot of opportunities. How stainless steel industry is gearing up, and what should more be done by industry to support these developments?
See, stainless steel is going to be widely used in many applications. Nowadays, we are seeing so many applications in day-to-day life which are galvanized iron or carbon steel converted to stainless steel. So most of the people are preferring stainless steel, even for domestic application, even in construction industry and everywhere, furniture industry, of course process industry uses it. So there is a huge potential for stainless steel, but from the stainless steel manufacturers, we expect stable pricing for stainless steel, and something has to be done to keep the pricing in check so that it becomes an affordable material for everybody.
Yes. I think pricing is definitely a very delicate issue which I would not like to discuss today in this forum. Let's focus on new applications and new developments. And thank you very much, Mr. Verma.
Thank you.
And now I would like to invite our next speaker, Mr. Abhijit Dani, from Praj Industries. Yeah, please. No, you go, I'll do the introduction. So we have another gem of a person here. Mr. Abhijit Dani is a vice president and business unit head for 2 business units at Praj Industries. Since December 21, he heads process equipments and modularization business unit, as well as business unit for water and wastewater treatment. And as you know that all this industry, they require a lot of stainless steel of high quality, high performance material. By education qualification, Abhijit is a mechanical engineer, MBA in marketing and finance, and he was selected for prestigious Fulbright scholarship to attend advanced management and leadership course at Carnegie Mellon University, USA in 2013. So I have a very biodata which is with lot of accomplishments and lot of achievements. So without taking much time, I will hand it over to Mr. Abhijit Dani to present his views on ethanol industry especially. Thank you.
Thanks, Rajiv. Good evening, everyone. I will speak more about where I'm coming from, of course, my company, Praj Industries. And I will also talk about what are the expectations from ethanol industry towards stainless steel manufacturers and the overall ecosystem, and what challenges do we see and how do we collaborate within the ecosystem to find out sustainable solutions to that. Can you go next? Some background about Praj. Praj is one of the leaders in ethanol industry. It's on the forefront of ethanol revolution. It's almost 40 years old company and a leader in biotechnology space. So as you can see, we have a presence across more than 100 countries for more than almost 1,000 references across the world. We have been rated as best place to work in bioeconomy. Can you go next? We have multiple businesses. Of course, bioenergy is their big business, core business, and we have also pharmaceutical water business. We have engineering businesses and water solutions and R&D. So in most of the businesses, fundamentally we use different grades of stainless steel. All the plants, say bioenergy plants or even, of course, pharmaceutical water, all need SS316L. In engineering business also, it's a mix of stainless steel and carbon steel. But of course, from percentage usage perspective, stainless steel becomes majority of the material. And in effluent treatment also, because these effluents are very corrosive in nature, most of the time we have to go for stainless steel equipment in our ZLD offerings. So overall, if you see, Praj becomes one of the largest OEMs as a customer for stainless steel industry, and that's where I would like to share our expectations with the industry, that as representative of ethanol industry, Praj has certain expectations. So can you go to the next slide, please? We are promoting green technologies. Green technology is the backbone of our company, and one of the most important expectation is how do we promote green steel in our operations, in our plants. So that is one of the expectations from steel industry, that how do we contribute as an industry towards total decarbonization of the industry. Then innovation in grades, particularly for ethanol, it's a low pressure application, so the thicknesses are mid-size or low thicknesses, and that's where we are struggling to find an alternative to SS304. Of course, there are some grades which are possible to be to replace 304, but at low thickness it doesn't make economic sense. That's where we expect stainless steel industry to do some innovation and find out what can be the composites, like Ravi explained, that can there be possibilities where we can find a more economically feasible grades of stainless steel. That will reduce overall cost, but of course, too much dependence on nickel prices. Raju will not like it, but still that's an important aspect to look at. And there is one more expectation that in India we see ethanol revolution shaping up in a big way, and we expect substantial increase in demand of ethanol. So naturally the demand for setting up new plants will increase. So we expect a large demand of stainless steel from ethanol industry. And how do we, as an industry from stainless steel perspective, what is the capacity addition which is coming up, and also how to establish a fair competition within the SS industry value chain. So that's one of the expectations we have. Of course, I will also talk about some of the challenges. Can you go to the next slide, please? So as an important part of value chain, we see some of the challenges which are in front of every one of us. How do we build resilience across the value chain? Currently in this VUCA world, the entire risk and challenge is concentrated on the equipment suppliers. What's happening, that whatever change happens in terms of price and availability gets the equipment suppliers gets affected the most. So that is one of the important aspects that across the value chain, right from stainless steel suppliers and down, upstream of that to the actual owner of the plants, how do we mitigate the risk across the value chain? That's one of the important aspects and a challenge we need to work together. Today's unprecedented situation in pricing and availability is creating a lot of problems in industry, and particularly in some cases it is actually affecting the feasibility of the project. And that's where sharing of risk equally by all the stakeholders is going to be important aspect. I will not talk much about equipment because Mr. Alreja is already there, so individual equipment I will not talk about. I will talk about more about plant, entire plant, including piping, walls, and all SS-based material. And one of the aspects which probably we all need to think together, how do we establish a very predictable pricing mechanism, very predictable availability of material, considering the variability of the input material. This needs to be established to have a realistic assessment of the project timelines and the project costs. So that's one of the aspects, and I appeal to SS industry from the user perspective that these are the challenges where probably all of us, in all the stakeholders, need to work together and find a sustainable solution. Thank you.
So once again, a great presentation, and the points which are raised are quite valid, and it's very nice to hear that end users are looking for sustainable stainless steel, and that is very important for all of us, that how do we make sure that we do not have too much of burden on our Mother Earth, and how do we increase recycling, how do we use more of green energy and concept like that. Regarding supply chain and regarding the pricing mechanism, I think it is the time that industry also should think about innovative ways and work with the customers in a collaborative way, because demand or expectation can be different from different industry and for different projects. So it is important for the industry to make a note of it and see how we can help the industry to grow. And at this point of time, I will request if there are any questions from the audience.
Or you depend on the already existing stainless
currently, we are fundamentally using the grades which are available from the stainless steel suppliers, but our idea is to collaborate with the stainless steel manufacturers to jointly work together to find a better grade. Yeah. So a better grade in terms of, for these particular applications in ethanol, we have been trying to find out what can be done apart from stainless steel, but we are open to collaborate and find out newer applications. Of course, metallurgy may not be our core strength, so but our expectations and our experience can really add value to the stainless steel industry. Yes.
No,
Thank
actually,
you.
based on feedback from the customers, stainless steel industry is also continuously developing new and new grades, and it is a continuous process. Once we get more feedback, more expectation, it gives us more challenges and more opportunities to develop new things. So for the stainless steel industry, it is very important point that we have to continuously upgrade ourselves. Thank you very much for your question.
Rajiv, I have a question for you. I believe ethanol is already is prevalent in a very big way in Brazil and other markets, where you as an international company developing new grades are already present. So are you also planning to offer some, you must be already servicing those industries. Are you looking at bringing in new grades to India also, or offering them to the Indian customers, which are more suitable for ethanol related either storage or production and things like that?
So if I understood your question correctly, you are asking whether are we offering complete range in India market that we are producing?
Things which are more product centered to the ethanol production and storage.
Yeah. No, actually, as of now, I think, Abhijit, we are currently trying to see which is the most suitable grade in the existing portfolio. And as we received another question, that if there is some requirement, that whether we have to develop or make some changes or improvements in the existing grades, we can have open discussions.
Yes.
Actually, you are from industry, I am from academia. So we try to learn from you. My question is that most of these products that we are making in stainless steel is through ingot metallurgy route. And second thing is, as you said, that your company is a diversified company. You are also related to bio and things like that. Stainless steel is a passive material and it is used for even implants and things like that. My question is very straightforward. Some question was there about the innovation. This innovation may be in the process innovation, like, are you using digitization, artificial intelligence, IoT in production so that you can minimize the cost and compete in the world? That is one thing. Second thing, are you thinking of, is there any applications of additive manufacturing of stainless steel in industry?
Thanks. This is very interesting questions, and as you said, we learn from each other rather than one learning from other. So, of course, I will answer one by one about digitization and Industry 4.0, including IoT, etc. There are certain applications which definitely we are implementing, particularly in digitalization, which is a big drive in the company. We are actually, we have an innovative solutions towards commissioning of the plants. We have a remote bridge application which we designed ourselves, and actually our engineers commissioned the plant remotely in USA. And we are also helping customers there by monitoring and ensuring the plant is working properly through this remote bridge, and that has been helping everybody to, overall reduce the operational cost in terms of, how do we predict the performance of the plant, etc., and predicting the potential failures, etc. Coming to additive manufacturing, it's in the nascent stage. in our kind of industry, you know, the sizes are too big. Yeah. Uh, so additive manufacturing is yet to take shape, but I hope very soon we will have a bigger 3D printing machines which can make this complex equipment a reality. There are possibilities which we are exploring for smaller components and very complex shapes, which can be done through additive manufacturing. But I think it's a movement towards right direction, but we are not there yet. So I hope that very soon we can see, like I have seen a rocket made through additive manufacturing. We are yet to reach there. Thank you.
Thank you. And Abhijit, if I can ask in relation to stainless steel industry.
Yes, thank you. That's an important aspect. From climate change perspective, the entire world is moving towards decarbonization, and our government is very progressive from that perspective. We have taken aggressive targets. So till now, the blending mandate has been 10%. Current capacity is just almost like the meeting the 10% mandate. I think we have reached 8.4% blending as a country. Earlier, the targets for blending was 2030. So by 2030, government wanted to reach 20%. That means double the blending now. And after the recent policy changes, very progressive declaration, and the target has been brought down from 2030 to 2025. So that means in next 3 years, there will be almost equal capacity addition in the industry. So currently we are, in India, we are producing 700 crores liter of ethanol for blending, and equal capacity has to be installed within next 3 years. So that's a very, very aggressive, very, very ambitious project. So from that perspective, if you see that this much of capacity addition is, if required in ethanol industry and the plants need to be built, we expect that around 1 lakh tons of stainless steel will be required in next 3 years.
So big round of applause for stainless steel industry. Another demand of 1 lakh ton coming in 3 years.
So, and that's where we were wondering that, okay, considering the current situation of availability in 3 years, 1 lakh tons of stainless steel, if it is required, are we really prepared and ready?
Thank you very much, Abhijit. Thank you very much.
Please.
I've been reading that in Brazil, you know, the ethanol up to 80%, 90%, even 100% is used. Is that a feasible solution, or there are any restrictions on using such high percentage of ethanol as a fuel?
Definitely it's feasible from perspective of usage. Of course, there are certain challenges in terms of going from E10 to E90 because the engine needs a little bit of tweaking, etc. It has to be a flexi fuel engine also. So technical feasibility, yes, but from availability perspective, from the capacity, as I said, installed capacity perspective, we are still not there. So Brazil, they are using it, but India, it's long way to go.
Because it's very high, 70, 80, 90, and even said some cases even 100%.
Yeah, it's 100%, but generally
that's
it's
a figure which is staggering. I think it is much easier to make ethanol than look for you know, fossil fuel. You know.
Yeah, of course. So currently we are at E10, and the highest range is E90 or full ethanol. So it's a big gap, and hopefully we reach E20 very soon in next 3 years. And that's where it's a good movement forward, I would say.
It is moving from a available source where we can make it to a source which will end one day. You know, fossil fuel is not going to last forever.
Yeah. So feedstock has always been a concern. We earlier till now we have been making it's a 1G, so first generation ethanol, which is from sugary or starchy feedstock. Now in Praj we have developed this technology of ethanol from biomass, lignocellulosic biomass. So it's called 2G second generation ethanol, and that will be a game changer in terms of availability of feedstock. So we are the only company who is actually building 3 plants for our OEMs, OMCs like IOCL and HPCL, etc. So this is going to be a defining time for ethanol industry also.
Do you think that in the near future we can see something like this happening in India also?
We'll have to see how the future unfolds.
Ethanol we can produce at least.
Yes.
But if we don't have a mineral fossil fuel, we can't do anything.
Yes. So from the energy security perspective, the more we produce in within the country, better for our energy security.
Thank you.
Thank you.
Thank you, Abhijit.
Thank you, everyone. Thank you.
Yeah, great presentation. And now I would like to introduce Mr. Rajesh Alreja, who is the Vice President, Engineering and Procurement, Process Equipment Division of Godrej and Boyce Manufacturing Company Limited. Mr. Alreja is a mechanical engineer from Mumbai University with a post-graduation in business administration. He has 4 decades of experience with various process equipments. And for the oil and gas, power and related industry, he has dealt with various international end users, licensors, EPC contractors, involving various metallurgies of construction for the process equipment. And he is our expert of stainless steel industry, who is going to talk about how the stainless steel industry future for process equipments, and looking forward to hear from you.
Yeah, good afternoon. So I'll try to be brief. Before I go into this presentation, so Mr. Verma spoke about hydrogen, Mr. Dani spoke about ethanol. So let me give you a little bit 1-minute brief on hydrogen. So hydrogen has always been produced. Traditional method is you take any hydrocarbon and you remove hydrogen from the hydrocarbon. And so this is what now is being called as gray hydrogen. And so some people wanted this carbon, whatever is left out, not to be sent to the atmosphere. So if you capture the carbon, then you start calling it blue hydrogen. So what is green hydrogen? So people want to do green hydrogen. So what is green hydrogen is nothing but don't remove the hydrogen from the hydrocarbon, but remove the hydrogen from water. So you take water, you put an electrolysis and separate the hydrogen and oxygen, and that hydrogen is called as green hydrogen. So now, is there any plant yet of green hydrogen? Not yet. There are various people, various technologies. People are trying out various things. What will succeed, what will not succeed is not yet known. There's only one plant that I know of that is under construction, that is in Saudi Arabia, NEOM, which is in green hydrogen. That is a biggest plant, that is 2 gigawatt capacity. Now again, the challenge what you heard was how do you transport hydrogen? What pressures, what temperatures and all. So there is one more method of transporting. You take the hydrogen, you get nitrogen added, make ammonia, then transport ammonia and then crack it back at the place that you are doing. So that is what is being done at NEOM, and there are many, many people working on it. Many different technologies are working. What will succeed, how we will reach, we still don't know. So now let me just introduce what we do. Godrej as a company, I believe everybody knows, but I don't know, we are not very popular for the type of equipments here. We are more popular for locks. We started making locks, we still make locks. And we make appliances, refrigerators, washing machines, and so many other things, but there is one of the division where we make process equipment also. So Mr. Dani said they make equipments for the lower thickness, and so we concentrate on the high pressure side of the equipment. So next slide. So we started off in 1976, now we are 45 years young. Hope to keep growing. Godrej incidentally is more than 120 years old. And we serve the oil and gas, power, water, chemicals and fertilizer industries. Next slide, please. We have, whatever you see blue is where we have supplied the equipments. It's all across all the continents except Antarctica, because there are no such equipments yet at Antarctica. 30 plus countries we are served, and many, and still counting. We want to make this whole graph as blue. So as I will not go into more details, so reactors, pressure vessels, columns, exchangers, in the oil and gas sector, and then power. We have recently taken over an organization in the United States, so we are into the surface condensers and feed water heaters for the power sector also. Next, please. So we deal with all kinds of metallurgies. So we have metallurgists, yes, we deal with all kinds of metallurgies. Just to answer your question, do we make new grades? No. Do we use all the 101 grades that are there? No. We ask them to give a lot of modification in those grades, so it's always niche. If 316L is 1711, then we will tell them that I don't want 11%, I want 12%, and I want this much extra, and I want that much extra. So we just try to trouble them a lot. So that is where we are. So as I said, we are into the high pressure side, and as rightly said, for gas processing, you have temperatures very low. This particular equipment has a temperature of lower than -100 degrees centigrade. We made this whole equipment in stainless steel. If you can see, this equipment is weighing 640 metric tons. The thicknesses are about 100-120 millimeters. So still in India it is not made. I believe we had bought it from Outokumpu at that point of time. At that point of time, Outokumpu made this thickness for the first time. So we are always trying to go to the border of the capabilities, and so we keep asking them for doing more. So this is another application. This is in a fertilizer plant. We supplied it in Uzbekistan. You can see 400 ton. This is again solid stainless steel. There are a lot of internals, pipes and everything there. It is, again, as you said, standard grade. It is, if you see the grade, 304LN. So what are we trying to do? 304 is a very standard grade. If you put L, it has got slightly higher corrosion properties, but the carbon is less, therefore the strength is less. Now we want strength also because we want to save the cost. So we add nitrogen and make it 304LN. So these kind of innovations is what probably our industry keeps talking about. Then we still want to save cost. So, and still higher pressure, if the temperature permits, then we use clad steels. We have a double layered material, carbon steel on the outside, stainless steel on the inside. So inside we have the corrosion properties, outside we have the strength. That's what we try to do. So our requirement from the industry, infrastructure exists in India to produce this clad steel. Do we produce it? No. We produce carbon steel separately, we produce stainless steel separately. Worldwide, the same plant manufactures clad steel also, which we don't. We have been after the industry to start making it in India. Then when the thicknesses are more and the clad also doesn't work, then what do? We just take a stainless steel metal, we melt it and then overlay it inside. That means the whole equipment is overlaid inside. 5 mm layer of stainless steel is molten and put across the whole equipment inside. So we still get whatever we need. So then we need those kinds of material for doing the welding in stainless steel. Again, these are currently mostly imported. There are manufacturers who do it, but again, not yet available in India so much. Next, please. So these are many internals that go into the equipment that you see. These are all stainless steel, various shapes, sizes. Sometimes the stainless steel itself is not good enough because the corrosion properties and all that we demand that stainless steel also, we require slightly better metal. So we use nickel alloys, inconels and other things. So this whole equipment is again clad, means same the overlay with inconel that we use. So it's a higher material. Next please. This was some years back, this duplex stainless steel came on. So that was basically giving you the same or slightly better properties than 316L, but having only 5% nickel, 2205. So that was the standard duplex, 22% chrome, 5% nickel. Other than 316L has a 11% nickel. So the nickel goes down, so the price should go down. It doesn't really go down, but it's supposed to give you slightly better properties. So this is for an offshore application in Australia, in an offshore plant, because in offshore you have sea water all across, and so you need that kind of thing. Next one. In this we use tubes. You must have seen various stalls here supplying tubes, and most of them, many of them we buy tubes from. So there are a lot of tubes inside this, and this is a Again, a 350 ton. As I said, we concentrate on the high tonnages and high pressure equipments in this industry. Next, please. We also go into titaniums. Not a topic for this industry, but yes, this titanium also can be replaced with with some stainless steel in some applications. We do use 316L also, or certain grades of this, but we also use titanium. Again, a very high pressure application. Again, tubes are stainless steel. So I just wanted to give you a glimpse of the type of equipment that we make. To answer your question, are we looking at additive manufacturing? These all equipment that you saw, they follow under the ASME, the American Society of Mechanical Engineers, and we are bound to follow their protocols, and we can only use materials which are listed in the ASME code. So to my understanding, there are 16 subcommittees now formed which are trying to allow additive manufacturing and those into the ASME code. And as Mr. Dani said, it's not near, and knowing by the space which you get may take about 10 years. But they made one component and they have used it, and that is coming. How large a component, whether we will replace the whole thing or some specific combinations, or so they have selected that it will be in powder forms. So the powder will be sort of melted by lasers and all, and you will make a component, and that component will need to be heat treated so that it gets the strength, just like sintered products, how it is there, something like that. So that kind of committee has been formed and they're working on it. So I hope it will come sooner rather than later. Again, anyway, so I wanted to make it brief. We are less time.
Yeah, so this presentation was something which opened our eyes. So after seeing such large equipments being made by Godrej and exported worldwide. So definitely it is a very proud moment to see this presentation for all of us. And stainless steel industry also can feel very proud as associate with Godrej, and then whatever best we can do to support. But if I like to ask one question, that other than the price, what is your expectation from stainless steel industry to do more?
So there are two things I would say. One, as whatever is being pointed out, that it is a niche industry. Our volumes are not may not sustain you. So maybe we buy only 5% of all the stainless steel produced by you. It's a niche market. So currently the industry is not geared up for niche market. They are looking at volume. So if we need something extra, 1% more nickel or something like this, some combination of, because now what is happening, we are operating at such a stage that you may require corrosion properties also, you may require strength also, you may require some other aspects also. So there is some tweaking required. And according to us, it is possible, and currently the infrastructure is available to do so, but we need the industry to sort of reach out or live up and say, yes, we will support, we will work, because once those get developed, then those technologies then have a cascading effect on going at other places. So we would expect that have some sort of, for the niche players, have some allocations or something that the industry should do. So that is one. The second thing, I will not talk about price, but we find the volatility, like, okay, Russia, there is a problem. Russia supplies 10% nickel, fine. 10% nickel stops, market is totally volatile. Now suppose, let us say the stainless steel demands become 2 times. Is the industry, how is the industry going to cope up? We don't know. Because then what happens is, if we go that path and suddenly we are not supported, it becomes very, very challenging. They need maybe 1 lakh tons more. But by adding 1 lakh tons more, suddenly the prices are going to have totally different. That is also something which is, again, I am not saying current situation, but do you have that wherewithal for that growth? I am not very sure of it.
No, your points are well taken. And definitely industry needs to understand the pain areas and work on it. Any question from the audience, please?
Actually, there are no problems with materials, but there is problem with us. We do not know each other. We do not know what other person is doing. If you look for this additive manufacturing, Raja Ramana Center, they develop lasers. So 10 years back, one of the scientists, he did PhD under me when I was in IIT. And we did all these laser manufactured, this thing is stainless steel, Inconel, and then we went for not just tensile strength, but we went for fracture toughness evaluation. K1C, J1C, fatigue, crack growth, structure property correlation, Now I'm finding that laser rapid manufacturing is coming after this 3D printing has come. So, but we do not know each other. So my complaint is with the industry, of course not with Godrej. Godrej is the learning point. I have visited Godrej. I know Mr. Vaidya, who was from IIT Bombay. And you have got scientists from ISRO, you have got scientists from, you are helping BrahMos. It is just to see it, to believe it. Because what I said is the interaction. When you talk of this stainless steel, I remember one project from ISRO, because you had got ISRO scientists in your place also. They are working on different projects. So for your SLV program, we also use hydrogen. So your temperature is minus 180, minus 190 degrees centigrade, and those structures are welded. So they had a problem that what will happen if you store hydrogen, because you have to do a pressure testing. So they wanted to test this material properties at minus 190, 200 degrees centigrade, and that also not tensile strength. They wanted to do fracture toughness. And those machines were from USA, there was an embargo. So we somehow manipulated this and we tried to do that. So there is a lot of information. On the basis of that, ISRO just said there is no need for doing this pressure test. So when we work with industries, there is always a scope, that we can help each other. And after all, when you interact with the students, it's your corporate social responsibility also. So my appeal to you, all of you, is that don't neglect the youngsters.
No, we never do so. So thank you. Point taken, sir.
Thank you very much, Mr. Alreja. Thank you very much. So now we have Mr. Mrinal Das. So I have kept the best in the last for you. So please welcome Mr. Mrinal Das. He is the Senior Vice President, Projects and Engineering Purchase of Dorf Kettles Chemicals, Mumbai. He has over 30 plus years of experience in petrochemicals, refinery, fertilizer, special chemical industry. His experience is mainly in project domain, with strong exposure on material of construction, corrosion study, cryogenics, quality control, and process engineering. He also has very sound knowledge of hydrogen and syngas technology, mainly in ammonia and methanol plants. So over to you, Mr. Das. Looking forward to hear you.
Yeah, I think this is the last session, so you have to have a lot of patience. That is the first thing I would like to say. See, my colleagues have talked about hydrogen, they talked about ethanol, but everything, this actually hydrogen, ethanol, methanol, everything goes into specialty chemical. So if you see, the specialty chemical industry is actually a very interesting domain, which is growing in a big way. Can you put my presentation, please? So till the time they are presenting, I'll just tell you about Dorf Kettle. Dorf Kettle company, DORF stands for drilling oil ketone aldehyde. We are one of the largest company who are supplying, the specialty chemical in refinery industries. Water treatment, corrosion inhibitors, drag agents, and also we are one of the largest manufacturer of xylenol, which is a raw material for Dettol. Nobody will be knowing, but we are the largest producer and supplier of that raw material, which we supplied during pandemic. So it was one of the very highly demanded product which we are doing. So I think the presentation comes on, I will go. See, specialty chemical company is basically a part of the chemical industry who are making very specialized chemical for crop science, agro science, then for the pharma industry and for the chemical, petrochemical also. These are very special, whatever you use in your daily life, even in your medicines, in your pesticides, all these ingredients come from the specialty chemical. And one very good thing I can tell you, all the shares of these companies have gone up more than 2,000 in last 1 year. And it is going to rise further. Why it is going to rise further? I will just tell you, because the global companies are trying to de-risk themselves. And in India, because of the Chinese issues, we are, all the companies are growing. They have started manufacturing. Almost 22% of the total chemical and petrochemicals, they constitute the specialty chemical domain. And the growth today is about 11 to 12% CAGR. It is going to increase further. It is expected it can cross 20% also. The way if you see all the industries, not to name, but there are companies like UPL or Navin Fluorine or Aarti Organic, Deepak Nitride, I can name so many companies. They have been fabulously performing. And if you see many companies, even like Lakshmi Organic, where I was working before, they have got listed. And now they are also crossed 500, close to 500 in the share market. So all the companies are doing fabulously well. And they are growing, they are expanding. The capexes are growing up. Last year, the capexes were about 6,000 to 7,000 crore. And it is going to expand not less than 10,000 crore. So if I say 10,000 crore capex in specialty chemical, what is the potential for the stainless steel? The stainless steel, so I think this presentation has come if you can read, but you can go to the next slide, please. Third slide, please. Please go to the third slide. Yeah. So all my colleagues talked about so many grades, stainless steel, other alloys, nickel, price volatility. So it is directly affecting the specialty chemical industry because the capexes are already worked out. And the prices are going, they're very volatile. So if you see the Indian specialty chemical capex, it is expected to be consuming about minimum 3,000 crore of stainless steel. That is expected. And it will be much more than that. Even the prediction is it may be double. Because if the Chinese things are not opening up again, the logistics, then most of the chemicals we are getting from China is going to replace to be manufactured in India. So the grades which we use in this industry, mainly they are 316 and 316L. And there is something which is, sometime you have to add titanium for specific corrosion use. 317 is used for the slurry and other applications. 310, 321, 347, my colleagues talked about it. So these are the highly demanded grades of steel which are going to be used in this industry. So there is a great future for stainless steel industry in specialty chemical industry. And 410 is one of the other one which is very much used in case of shafts and other things. Duplex, super duplex stainless steel is also coming up. And there is a lot of gap in understanding because most of these companies have grown from a very small companies, small scale. They have not been very professional or they have not catched up with all the specs, the development in stainless steel world, the new alloys like what Autocompo is making, a lot of duplex grades. They have so many grades. I remember having discussion with Autocompo on the acetic acid use. They have a special material which reduces my weight, which reduces my cost. But people don't want to experiment and they are not exploring. So as rightly said by one of our colleagues, there has to be connect between industry and the suppliers. Unless until we have a very close connect through this kind of exhibitions and other forums, we will not learn and will not know how to reduce the cost. There are options, but only 304, 316, this is what is talked. So I think we have to come out of that. We have to see what are the hundreds, 200 grades available, how we can fit in, how we can alloy it, how we can ask the, like companies like Autocompo and others, how they can help us to make special alloys. I think these are required. And I think you just saw from Godrej's presentation, I don't have to repeat, but the major areas where we use stainless steel in chemical industry or any petrochemical refinery, they are mostly the reactors which are handling the reaction process. First raw material is put and you get a product and then you purify it. That is a major process. So major, it is all corrosive. In chemical industry, you use glass lined, you use haste alloy, ink alloy, and stainless steel. But stainless steel contributes more than 50% of the cost. And the consumption of stainless steel is 50% and more. And mostly in the columns, tanks, storage tanks, vessels, piping, huge amount of piping is used in stainless steel. Fittings and flanges, valves, internals, and instruments. Instruments also uses a lot of stainless steel, including if you see the tubings, they are all SS316. So to just sum up, I would say that specialty chemical industry has a big growth in India and stainless steel will complement that industry, and it is going to grow together. So that's all from my side.
So another good presentation and lot of good news for stainless steel industry. In all the 4 presentation, one thing was common which I could notice, that all of us are expecting a huge demand of stainless steel industry, and it is up to stainless steel industry to cope up with that and to have very close interaction with the end users for new application development, for new grade development, and definitely it will give lot of benefits in the return. So thank you very much, and can we take 1 or 2 questions if it is
Please,
okay?
please take.
Sir, it was just a coincidence. When you are going to present your talk, suddenly L.I. Perumal's first slide appeared. So I thought that you have some relationship with corrosion. And whenever there is name of corrosion, L.I. Perumal appears. We are in the background. But,
Thank you.
but to look here, I remember company is so proactive that I got one of the, when you said Dorf kettle, I remember I got a failure analysis from your company. It may be 30 years, I don't remember. So your company is very proactive that way, thank you to, that is type of cooperation that we needed,
Yeah.
Second thing is, I see Auto Campo. I remember they celebrated, centenary celebration of stainless steel some 10, 12 years back. I think when Suri was there, CEO, so in Delhi. So we have gone almost 110 years in stainless steel, and I have found that such industries are very proactive. They are supportive to have even as a corporate social responsibility, you are supposed to interact with young students, because, they are the problem solvers tomorrow. So I always, whenever I go to any convention, I just say that you try to give internship to our students, and this is the new policy of the government of India also. That is a corporate. So try to look into that, try to interact with us, and we'll give you the solutions.
Thank you. Thank you for that.
So maybe the one more question, that how do you see future of green hydrogen or green ammonia in India?
Yeah, actually, I started my career with ammonia and hydrogen as a trainee engineer, and I am seeing now again it has come back after 35 years in a big way. I think there is a great future for green hydrogen, but I think we need to understand what is green hydrogen, how it can be made green. Green hydrogen, to make it, I think very difficult part is to have all the inputs green. The power, the fuel, the raw material, everything source has to come from green. It cannot be from a fossil fuel or a different source. So it is very important that it has to marry together with the solar energy, which is also a green. So I think it is happening now. The cost of production of hydrogen by electrolysis method using solar is very expensive. But there are a lot of innovations happening across the world, and it is coming down. The cost is coming down and down. And now in India, I think the Adani Group, Reliance Group, they are going into green hydrogen in a big way. And I think there is a great future because hydrogen is the future fuel. It is going to be used for the vehicles. You will not see petrol, diesel or any other. Even EV, what we are talking, is going to be replaced by hydrogen by the next generation. Maybe our grandchildren, their grandchildren will find they must be using hydrogen cars or hydrogen aircraft has already started. Means there are a lot of experiments, even Daimler-Benz, and a lot of companies are doing research, and they have reached a very good program. Because I have seen some facilities in Germany of Daimler-Benz, of the fuel cell, and they are doing it. It sees a great future. And another is about ammonia. What is ammonia? Is basically a NH3. Nitrogen and hydrogen, if you combine, it becomes ammonia. Nitrogen comes from air. So air has got about 79% of nitrogen, 21% of oxygen. So you mix that. Hydrogen comes from many sources. Fossil fuel, maybe it is naphtha or crude oil, it may be coal, it can be from any other source by burning. And now from green hydrogen, when we are talking, it comes from a source like electrolysis water, and that too powered by solar energy. So I think it is still growing, it is still developing, the innovations are happening. But I see there is a great future, but it is going to take some time to have green hydrogen. But in the meanwhile, green ammonia is being transported because you can easily transport that. Ammonia you can liquefy at minus 33 degrees centigrade, and it can go in tankers by ship cargo. And now we can see a lot of ammonia being transported, and they are all green ammonia. So I think there is a big future, definitely.
Thank you very much. Thanks a lot. So with this, we end this session. Yeah, please.
So before you speak, I just want to thank Virgo for organizing this great presentation, giving us an opportunity to speak here, and all the audience who have come here to attend. I think you have asked good questions, and I think you should more and more participate. So I thank you all. Thank you so much.
Thank you for allowing me to speak. I don't manufacturing industry, but I come from the machine tool industry. I come from the machine tool industry, and one of the things which I am doing is, we have been talked about hydrogen, and it is the hydrogen cylinder manufacturing. Now today there is a lot of development taking place globally, and there are different types of cylinders, T1, T2, T3 and T4. But a lot of innovation, because T4 is a non-metallic liner, and people have their own innovations about it. It is considered to be the lightest, and it is considered to be the most expensive. But today, development has taken place with an aluminum liner, which is 2 millimeter in thickness, and can take a pressure of 300 to 700 bars. And this is done, the manufacture is done by, of course, backward extrusion, then spinning and flow forming. And weight-wise, it is like a T3 cylinder, T4 cylinder, but since it needs less winding, it is less expensive. So tomorrow, the future of these vehicles will be T3. We deal with the complete plant and machinery to manufacture the cylinders. If anybody is interested, you can please contact me. I'm SP Thakur from Machine Tools India.
Thank you very much, sir. Thank you very much for your input.
So, ladies and gentlemen, check. Can we increase the volume, please? Check, check. Actually, lady and gentlemen, I would say. Before we conclude, I would like to share a compliment for the moderator of this session. Sir, you have done a wonderful job. You are my favorite moderator for all this session. Can we please clap for him? We were on the topic, we were precise, you were on point. We did not move here and there, even like for one single slide. It was fantastic to have 5 of you on stage. Of course, we spoke about many different topics. We spoke about material selection, challenges, possible choices, green technology. And sir, आपने जिस तरह से हमें explain किया, एक smile के साथ में आपका जो presentation था, मैं इस इंडस्ट्री के बारे में बहुत कम जानकारी लगती हूँ, लेकिन आपने बखूबी मुझे भी कुछ सिखा दिया आज, बहुत ही बढ़िया. Also we spoke about stainless steel utilization and so on. Every individual right here, भाई थोड़ा सा वॉल्यूम कर दे भाई. Check. He thought like the event is almost over. Yeah. So every individual who is sitting here, along with the gentleman with me on stage and ma'am right there, is a successful individual. For me, if you are here, if you're doing something what you love to do, you're successful. With this, I would like to conclude this session. If you permit, can I just add one small quote? So, whatever you decide to do in life, make sure you give 100% effort and commitment. Because without commitment, you will do it only with your convenience. So, ladies and gentlemen, whenever you are committed, you will do it whatever it takes to. So, with this, I would like to conclude this session, and I would like to invite Mrs. Anita Raghunath on stage. So, Mrs. Anita Raghunath is the Director of Virgo Communications and Exhibition. Ma'am, I would request you to please present memento to the moderator of the session, Mr. Rajiv Sherry, MD, Autocompo, India. And now we'll present a memento to the panelists, starting from Mr. Rajesh Alreja. Mr. Mrinal Das. Of course, I think, saved the best for the last with this session, followed by Mr. Ravi Verma. Lastly, Mr. Abhijit Dani. And now I invite Mrs. Anita to please propose vote of thanks.
Good evening, everyone. Firstly, let me congratulate all of you and also thank all of you for being here. We had a very successful exhibition, sir. It was a great effort and a challenge to put up the first of kind exhibition on the stainless steel industry. But the journey was really good for us, and we had a lot of people like Rajesh Sherry and his company and Jindal Steels and so many other people who really guided us well, and we were able to put this exhibition together. And especially the knowledge forum which we put, we had touched upon various topics, right from stainless steel building the nation to how do we increase the per capita consumption, topics for railways, and so many things which we covered in these 3 days. I'm very sure that this is just the beginning, and stainless steel is the future product or the metal for the future. And we are very, very excited to work with this industry and work with all of you. Thank you for taking time and being here and passing on your knowledge to the next generation. So thank you, and I would like to conclude this session and look forward to meeting you all in the next year for the same exhibition. Thank you once again.